topic today is going to be charging systems, some of the newer battery technology. We're also going to discuss some of the existing battery technology and shore power. So these are all very important things. As everybody is well aware, boats have multiple systems on them. We use them for a lot of different things. And if they don't work properly, it can be quite annoying, especially if your air conditioning doesn't work right, generator doesn't work right, shore power doesn't work correctly. According to the insurance company's stats, 55% of all boat fires are electrical. That's a high number when it comes to boat fires. That's higher than it is for fuel-related problems. So keep that in mind. A lot of this is because we're mixing electric and salt water, two things that don't get along very well. So there's a lot of things that we have to pay attention to in electrical systems to make sure they operate safely. There's also a lot to how they are installed. So up until about 25 years ago, of electrical systems, it was kind of not guided very well, let's put it that way. With ABYC now, we have standards that the insurance companies look for. Boat manufacturers are holding themselves to, not only here in this country, but abroad. So boats that are being built overseas are now having to meet those standards to have those boats sold here. So it's really important that those electrical systems be to the current standards. A lot of things have changed just even in the past 10 years on those standards. You need to have that electrical system just briefly inspected and just make sure everything is the way it should be. I'll give you an instance that happens typically with a boat owner adding some electrical device. They go to the Harbour store, they buy some wire, they buy some wire nuts, buy some electrical tape, and you know it's the code for a house, but not for a boat. Codes are different in a boat. There's a lot more to it. Most of the wire that you buy at the hardware store is not marine rated. Right? So the wires that we use for marine typically are tin-coated multi-strand wire, and it's designed so that it can allow it to flex so that the wires don't fatigue and break. We do not use Romex. Does everybody here know what Romex is? Solid core wire has no place on a boat. The problem with that is when it flexes, it breaks and can cause problems. So these are some of the things that we need to really pay attention to in electrical systems on boats. So this is a fairly important topic, and one that I hope everybody will come away with having a better understanding of their electrical system and what's all involved. You're welcome. So with that, we're going to start off with shore power. All right. Before I jump into it too quick, a little introductory. So I'm not sure if everybody, I recognize some of the faces. My name is Erik Lostrom. I am one of the managers at Harbour. My role is the technical lead role at the marina. I have come from a background of boat building and naval architecture. I've been in this business now 40 years professionally. So as many people that started this business, I started out as a kid painting bottoms, waxing boats, and have progressed along. I went to school for naval architecture and professional boat building. That was back in 87, 89. So you can see I've been doing it for a while. I find the repair industry a rather unique industry because it's more challenging. I like the challenge. As you all know, boats are not quite like cars. I can't just go down to the auto parts store, buy a spark plug for a car that's 20 years old. Usually with boats, you're lucky if the manufacturer has parts for that boat after 10 years. Our industry is not regulated like the auto industry, so there's no requirements that they have to keep parts on the shelf. And a lot of these aftermarket parts don't fit the same, don't work the same. So we have to do a lot of creative problem solving, I call it, in this type of business. And that's where my focus for most of my career has been, is on this side of things. Just because I find it uniquely challenging and interesting. The other part of that is because I want to make the boating enjoyable for the people that own these boats, make sure they work the way they do. So that way when you go out, you have a nice afternoon, enjoy your cocktail, and not worry about the boat breaking down or having an unintentional failure. So a lot of this is to educate you on how to prevent those problems so that you will enjoy boating more. How many of you here boat more than 2 weeks out of the year? That's a pretty good showing, right? How many of you are mostly boating on the weekends? How many of you do a lot of your boating on the holiday weekends? So that's not, that's, you know, those are planned trips. So if something goes wrong and you're not able to use the boat, that's a big disappointment. And what happens with some people is they get frustrated because they lose those weekends because the boat keeps breaking down, whether it be just normal maintenance issues or other issues that are overlooked, or just in some cases the age of the boat that just needs updating. When you get frustrated, and what I usually see happen in this industry, people get rid of the boat because they get tired of paying money and not being able to use it, and they usually wind up buying a vacation home, going on a vacation somewhere else, or an RV. So part of the idea here is to keep you in boating and keep you enjoying it, because that's what we're all here for, right? It's a passion that we all share. So including all the guys that work at Haven Harbor, this is a passion. You have to be passionate about this business. It's not an easy business. So with that, I'd like to introduce, this is Curtis. He is one of our technicians and now been promoted to, go ahead and tell me your role.
Assistant Parts Manager and Operations Manager.
Curtis has a lot of background in electrical, mostly coming from...
I was on the automotive side for quite a while and did automotive electronics and mobile electronics for about 7 years, and then had an interesting turn and I started doing electronics restoration after fires, floods, chemical contaminations, stuff like that for insurance companies. So electronics has really been my core my entire life. Into the marine industry, that was new to me just a couple of years ago. And learned coming from something that is so organized, you know, walking in, like Erik said, to a parts store and saying, hey, I have a 1996 Chevy Cavalier. They can tell you exactly what parts are in your car. You can't do that with a boat. It's a lot more difficult. And the difference in parts, like he said, you know, it's easy to run even to the auto parts store and grab wire and go, well, it's good for a car. It's not good for a boat. The moment you put that wire in and you have salt water moisture in the air, that wire is degrading, falling apart, corroding, and literally disappearing inside the jacket where you can't even see it. So it's real simple in this industry to think you're doing the right thing and just kind of end up down the wrong path that's going to cause you a lot of headaches down the road. So that's kind of the goal today, get you enjoying your boating, make it simple, give you confidence in what you've got going on, give you a little bit of education on it, and also bring up some of the things that I think have been brought really relevant to particularly Haven Harbor this last year, which is some of the things that we forget when everything's going good. Between the two marinas this year, I think we have close to 20 boats that were affected by lightning. In over a 60-day period, there was a strike at North that affected, I think, roughly a dozen boats, maybe a little more. And then we had a strike here at South that affected 8 to 10 boats. So we've got quite a few boats that they lost their entire season. And although it sounds dumb, there were simple little things that they could have done to protect themselves that would have cost them $0. And it's just creating the right habits. So we'll be able to go over some of that stuff today. It's not just you getting hit. Boat in the corner over here, all the way in the corner is what got hit. We had a boat out on the T-head out here that lost his bow thruster and bow thruster controller from that strike. It runs through the entire electrical system in the marina, and if you're plugged into shore power, you may be part of the damage. So, Eric's got some stuff here that he'll go over on the basic stuff. He's going to talk a lot about shore power, the issues with shore power. He's got some good demos and displays here he'll show you. Eric, how do you normally handle questions? Raise hand in the middle and interrupt, or
just, put your hand up if you got a question, and feel free to ask questions.
That's the key.
Just
we're not here to put on a show. We're here really to help you guys and educate you guys. So if you have questions, put them up all the time.
Yes, Robert.
No, just time out, get these guys.
Yeah, let's get some chairs. We got more chairs stacked up in the corner here, so we can put out more chairs.
Just a little quick recap. Basically what we're talking about today is electrical shore power systems, charging systems, and the battery technology that's out there today. So if you have questions about the topics that we start talking about, feel free to interrupt so we can ask those questions, because it may be a question somebody else is probably thinking. So don't feel bad. So with further ado, I'm going to start off with shore power. So everybody here, I assume, plugs their boats into shore power. Is there anyone here who doesn't have shore power? Isn't that interesting? Right? So boats today, even a center console anymore, typically has shore power. We're plugging it into the dock, running battery chargers, might be running air conditioners off of that, appliances, microwaves, your outlets, anything like that. So those systems that are dependent upon shore power, or a generator or an inverter for that source, we really have to pay attention to how that system is being used, the do's and don'ts. And what I want to start off with is the most common problem with shore power. So I'm holding here the guts of a shore power outlet. This is off of the cord. I'll pass this around and you'll quickly see there's a problem there. So we plug these cords in and out of the boat, in and out of the pedestals on the dock on a frequent basis, every time we go to a marina. So one of the problems is if there's a load on that system and we unplug it, you're going to have an arc. Because if there's anything drawing on that system, as you pull that out and the resistance goes up, you're going to get a jump. Every time you do that, it's going to damage either the outlet on the pedestal or the outlet on your cord. So one of the most important things you want to do is turn off the loads and turn off the breaker on the pedestal before unplugging. Don't just blindly unplug them. 2, they're susceptible to moisture, right? Pedestals, they're out in the weather. Even though they got a cover over it, they're still susceptible to moisture. Guess what? We have high humidity here in the summer, don't we? That's going to be moisture. That's going to affect the performance of the pedestal and where you plug it into your boat. So what I recommend for those circumstances is keep some dielectric grease on your boat. You can buy a little tube. You can get that at an automotive store, the hardware store. We carry it here at the marine store. Put a little dielectric grease on the plug points so that when you plug in, it's going to help deal with that moisture. It's going to keep that connection good and keep the moisture out of it. The other thing too with these shore power cords, everybody knows you have to insert, twist to lock it. So it's got a little spade on there that's got to lock in. I see sometimes people not realizing, instead of twisting it to unplug it, they keep tugging on it. And that can cause the terminals to get loose and can damage the outlet on the pedestals. The other thing that you guys are going to run into that's a problem is your shore power plug on the boat. It's going to look like this. You might have the plastic version or you might have the metal version. Right? So this one is for a 50 amp service. And again, I'll pass this around and you'll see very quickly what has happened. So this one was a customer that called and said, hey, I'm getting intermittent power issues on the boat. And the air conditioners keep dropping in and out. Microwave keeps dropping in and out. And I can't figure out what's going on. Everything looks good. this requires some tools and some investigation to figure out what was going on. So we tested the cord tested good. We got to the boat, and we tested that, and we were getting high resistance values on one of the legs. So we pulled the unit out, and sure enough, the second line coming in would have been the red line for this 220 volt system. Water had been leaking down on it from a deck fitting, just above it where it was mounted in the cockpit. You wouldn't have thought that. You can't see it. So the water keeps dripping down, the copper in the wire corrodes, we put voltage through it, that corrosion adds resistance, so on and so forth. That connection keeps getting hotter, hotter, and hotter until it fails. Or, worse yet, catches on fire, which that one was on its way to becoming a boat fire. So these are some of the things that we have to look for and maintain on a boat, is that shore power connection, both ends, and your cord. If your cord has a burnt up leg on it, I don't recommend reusing that cord. Either buy a new cord or put a new plug on it. They do make plugs, we can switch them out. Sometimes it makes sense to buy a new cord. If the cord itself is starting to look pretty ratty, it might make more sense to just buy a new cord.
One other thing, Eric, just on the same subject you're talking about, is as we're talking about unplugging and plugging, and I'll let Eric go into a little bit more. If you have the screw-on attachment, that is very important and helpful, because as your boat sits there, sorry, I'll stand up. As your boat sits there and the tide goes up and down and all of that, your power cord may get pulled on and shift a little bit. If it's not in there tight, it will rock. As it rocks, it's creating those same arcs. Even though you're not doing anything, it's still going to damage your cord or your shore power outlet there on the dock. The screw-on pieces are important. They hold that plug secure in and stop it from arcing as it moves around. I know it's easy to put it in, turn a quarter turn and go, but take the extra time. If your cords don't have that, it is advisable. You can get new ends for them that have that. If it had it and that's missing, we carry, and I'm sure you can get them at most marine parts places, you can just get the new ring that goes on that screws back on. You don't have to buy a whole new plug. But those are very important for protecting your shore power system, your boat, like he said, potential fire.
Yes.
Little thing, very important to help protect it.
Yep.
So the pedestals have switches, but there are a lot of connections in the marinas that don't have switches.
So under the current electrical codes that marinas are having to follow, right, you have to have the breaker at the pedestal, at the point of plug-in. You're going to go to marinas that are older, that have not been updated yet to the current code, and the breaker is not at the plug. The breaker is at a panel somewhere on shore. You'll see this, you'll see here in our yard, outlets. If we have shore power outlets out here in the yard to plug in a boat to do service work on it when it's on a cart, the breaker is probably going to be at wherever that panel is for that line, not at that. Because on land, in that circumstance, it's not required. It is required out here on the docks.
Okay.
So you're going to find marinas. I can tell you, you go to an older marina that hasn't been updated, and all they do is replace the plug on the pedestal, and breaker's not on there. It's shore power. So I'm going to give you a perfect example of why that's a bad idea. So if you have a short at that plug, and you say you're 100 feet out on the dock, and that circuit breaker is 100 feet away, it may not trip. What'll happen is it'll keep feeding current to the short where it's connected to the point where you have catastrophic failure and it catches on fire. I can tell you in personal experience, in 40 years, I've seen about 6 active fires on a dock at the pedestal or on a piling where the plug was attached. Burn the dock up, never tripped a breaker. Come in the morning and there's the fire, the smoldering dock panels, smoldering piling, and the plug. Luckily the boat didn't catch on fire, and luckily it didn't go any further, but no breaker tripped. So those are some things to be aware of out there. So when you go to, which is going to move into my next topic, when you go to a marina that is updated. And we have breakers at the pedestal. We also have to have a new safety feature on there to break for milliamp or straight current or what we call AC leakage. So there's a problem with that. They're sensitive. Everybody's familiar with GFI plugs in their boat at their home. Doesn't take much to trip one. You can get a humid day. I know I have the same problem at home. I have GFIs on the outside of the house. I'll plug in, an electric blower or something, and on the humid days, it'll trip sometimes, just because of the humidity in the air is causing some issues. So they're very sensitive. So what's happening now, if you've got a boat, how many here travel to other marinas here on the bay? How many here have had issues plugging into newer marinas with the new style pedestals? So your shore power trips, when you plug in or you turn something on?
The short power trips under certain circumstances. It has nothing to do with what I have on or off on the boat. Sometimes it trips, sometimes
It doesn't. So, with the new marinas in this, more and more people are having this issue. All right, because of the new standard, it's going to be a bigger and bigger problem. So the one thing boat manufacturers haven't been really good about is catching up to these standards. And one of the things that prevents this problem is we can put in what's called an isolation transformer on the boat for that shore power system. So if it's a 30 amp, you put in a 30 amp isolation transformer rated for whatever your current loads are going to be. Isolation is the key word there. We're isolating the boat ground from the shore power ground. So isolation transformer becomes like a power source that's on the boat, kind of like a generator or a solar panel or a wind generator, something of that effect. So the ground is isolated to just the boat. So this usually protects you from those problems with the new GFI systems that they're using on the pedestals. So something I'm going to start recommending to our customers as we go on. One of the other problems is most of these boats have galvanic isolators to help with the stray corrosion issues. How many of you here know if yours actually works? Do you even know if you have one? Anybody know?
I know, because Taylor fixed mine.
Taylor, how many boats would you say you go on to that either don't have a functioning one or don't have one at all?
I would guess it's a little less than, maybe around 50% either not have one at all.
Yeah.
And of the ones that we test, I don't know, maybe 20% don't pass the test, so they're not functioning right.
That's pretty high percentages for a safety feature that you want to make sure is operating correctly. So these are some things. Galvanic isolator is a good thing. Oh, go ahead.
So just tying in here real quick, the galvanic isolators that are put out now, they're again, as we advance in features and technology, they are all now supposed to be fail-safe, which is cool and convenient. The downside with a galvanic isolator that's fail-safe is when it fails, you don't know. There's nothing that indicates and tells you that it's not doing its job. It will still pass power to the boat. You can still use everything on the boat. You won't know. It's something that you have to kind of have checked periodically. It would be really nice if they would just put the little tester in itself and put a light on it that tells you it fails, but they don't. So unfortunately, it is something you have to have checked. And real quick, and I'll let it get back to it, but as he talked about the isolation transformers, and he talked about it separating your boat, that is also a really, really, really good way to protect yourself from lightning. Surge protectors on, I can tell you from when I did restoration with lightning strikes, surge protectors, lightning strikes don't care about surge protectors. There's so much current, it'll blow right through that beast. Yes, it'll destroy your surge protector, but it'll continue on and destroy everything else down the line. When we're talking about lightning. Electric from, the power company, they do a good job. Lightning doesn't care, it's so much power, it just blows right through it. And they have their own issues too of if they trip. Just like these dock pedestals, your boat has no power. You're sitting there and your batteries are depleting. If you've left something on, you may end up in a situation where now you got no bilge pumps because the refrigerator ran it dead. You thought you were plugged in. So there are ways to deal with all of this, but the isolation transformer offers you multiple benefits. It helps protect you at the boat with just your regular power issues, but it also helps protect your boat from the lightning. So it's an added benefit. It's two pieces. And it's probably, in my knowledge, and Taylor and Eric can chime in if I'm wrong, but in my knowledge, I'm pretty sure it is as far as lightning protection, it's pretty much the safest way you can go to protect your boat. You still have a little bit of risk if you have metal through holes and stuff in the water, or bow thrusters, etc. But the shore power is your biggest risk if you're not the direct strike from lightning, and an isolation transformer eliminates that issue.
Yeah, there's some other features of the isolation transformer which I'll go over as well. But it's something you definitely want to start thinking about with your boat. If you've got shore power system, the other part of that is because we have battery chargers that use circuit boards, we have air conditioners that use circuit boards, we have appliances that use circuit boards. They're all very sensitive to power surges. Or they're also very sensitive to low voltages. Circuit boards do not like low voltage. So here's a really good example of what can happen and how that works. Let's say you're over on Blue Dock over at Haven Harbor North and you're all the way at the end. Right? That's a pretty far run. And it's a hot summer's day and all the boats going out, all 50 or 60 boats on that dock have their air conditioners running, their battery chargers going, fans going, all that demand on the system going out the end of that dock, and you're on the end running your 4 or 5 air conditioners on board. I guarantee you the voltage that you're going to read at your pedestal is probably going to be down closer to 90 volts because we're going to lose voltage due to the demand on that dock. Well, guess what? Computer boards that control your air conditioner or your battery charger don't like low voltage. It will damage them over time or it'll damage them quickly. I've had customers that had a 60-foot yacht over in Annapolis. He was on the end of the pier, hot summer. Every summer I'd get a phone call. I got 2 air conditioners out. My inverter charger's gone out. Every year we're replacing those components. I was replacing circuit boards or motors or the inverter charger. So I decided to do a little investigation on his boat to see what was going on because it just seemed odd that he kept having these problems. He was chopping it up to maybe a lightning strike because there was, thunderstorms on the bay here are pretty common. So I did a little checking and I found that his dock pedestal, with the systems running, and all the other boats that were on that dock, his voltages were down around 90, maybe 100 at times, depending on when things were coming on and off. Well, those systems don't like that low voltage. It was damaging the circuit boards, and every year he was having to replace something. Now, fortunately, he could afford it. He owned a 60-foot motor yacht. It wasn't something he was going to do on his insurance, but at the same time, he was getting very annoyed with it because every time we go down to use the boat, something wasn't working. So when we did the investigation, I found he's losing that. So I looked at the boat, and I checked the shore power system on the boat. And what do you know? The builder did not put in an isolation transformer on a 60-foot motor yacht that had 7 air conditioners, a washer dryer, refrigerator, 2 ice makers, all these appliances. That's a lot of systems on the 110 volt side. So that's a lot of demand. So I convinced them we need to put an isolation transformer in it. We put that in there, all the problems went away. No more electrical issues with the boat. He went for 6 years before he sold the boat with not having anything fail, whereas before that, every year something would fail. And we were having to replace a circuit board. I even replaced a circuit board for the trash compactor. It was implement. Just happened to use it at the right time when the voltage was low. So these sometimes mystery failures, there is a cause. So we need to really check things over. And this is where it's really important. If you've got a marina that's got good marine electricians, have them check it over. It's well worth the money to have that system looked into to try to keep your boat working right and avoid an unintentional fire or failure.
I'm sorry, I gotta ask, how does that work, the isolation transformer? Because if you've got 90 volts coming in, how can you have 110 coming out?
Good question. I was waiting for somebody to ask. So isolation transformers, everybody's familiar with, they see transformers out here on the power posts, you know, that come off to come to your home or to a business, whatever it might be. So that transformer is basically just a bunch of big coils and stuff. And there's no physical connection between the power grid or the power source and where it's going to your house. So we're doing the same thing on a boat. It's isolating the physical part. It's using electromagnetic fields. Well, the other thing it does is that it's set for a certain, operate at a certain voltage. So on the boat side, it's set to work at 120 volts. That's what it wants. So if we have 90 volts coming in, it will step it up to 120 volts. So isolation transformer is going to transform the current coming in, or the voltage coming in, and getting it to the correct voltage to operate at. You'll have some minor fluctuations, which are normal, but basically that's what it's doing. And then the isolation part, again, is it's not a physical connection, right? So we're not plugging something in. You know, you've got the wires coming in from the shore side, and you've got the wires from the boat side, and you have your coiled fields. And the ground is only grounded to the isolation transformer on the boat side, not on the shore power side. They're isolated. So there is no physical connection between the two. And why is that important? Curtis was just talking about. One is lightning strikes, right? Here's another one. Power surges. What happens when the power goes out because of a storm and then it comes back on instantly? You get surges. So if your boat has that isolation transformer in there, it's going to help protect the boat from power surges, because they can do damage. Again, electronics, circuit boards don't like spikes, and they don't like low voltage. They like to operate right in their realm. So that's usually what damages them.
How large are they, and do they need to be in, they run hot? I mean, do you have to put?
They will produce heat.
Yeah.
Anytime you have something like that, coils, there's going to be some heat developed. So they have to be mounted in an area where it can breathe. There's got to be some ventilation provided for it. The size of them varies depending on what your electrical demands are on the boat. They make them in 30 amp, they make them in 50 amp, they make them in 100 amp. When you get into the larger, I'll give you an example, the 60-foot motor yacht with a very complex 220 and 110 volt system, that unit weighed about 300 pounds. So I put a generator in the boat. All right, so it's a big box like this. You've seen them on the poles, right? There's a transformer up on the pole. It's a big, heavy thing. Believe it or not, some of the European boats, the larger motor yachts for a while, when they would bring them over here and they would convert it for our voltages, they would actually use transformer, maybe a 100 amp transformer that would be mounted on a pole. I did one boat because his failed. It was down in the engine room. It was all rusted because it's not meant to be in a saltwater environment. And it's also not meant to be in an engine room. It overheated and eventually ruined the coatings on the coiling in there. So that transformer was literally, I went and looked up the part number, and it's the one, you know, GE or whoever, Delmarva Power out here puts on their poles. And the interesting thing is it's got hooks on it. It doesn't have a way to screw it down. So what they did is they mounted it upside down, took the hooks, flattened them to secure it in place. This was on a European-built motor yacht out of France, because it was easier to do that than try to get a marine version of that installed. It was a lot cheaper. So they had this thing in there upside down. The hooks are on there because the power company has a bracket on the pole and then hooks onto the bracket. So it's easy to take off and put on. So here it is mounted upside down. The cooling fins are now on the bottom, not on the top, like it's supposed to be. So the heat is building up in the system. So it didn't have any of the right type of installation. Again, here's a circumstance where using the correct marine designed equipment is important. not using something that would be designed for a different application. But it's a heavy item. If you're doing a 30 amp, they might be 100 pounds. Taylor, do you remember that one that had, I think it had two, didn't it? Was that Bavaria? That had isolation transformers on the shore power. I can't remember. I think they were small. They were small. They weren't too big.
Yeah, I think Victrons are a little smaller.
Yeah.
And then either Newmar or
Newmar.
Charles made some that
Yep.
kind of bigger and heavy.
Charles got out of doing marine ones anymore. I think it's Newmar and Victron, and there's another company. Yep.
Are these mandatory on newly produced boats?
Fortunately, there's no mandatory standard for it. My guess is that the rate at which marinas are, oops, sorry.
Finish his question.
The rate at which marinas are being bought up, updated here, in just in the U.S., that eventually all these marinas are going to be up to code to the new standard, and you're going to have more and more boat owners with this problem. So there hasn't really been a standard other than the galvanic isolator for galvanic corrosion issues. The isolation transformer, they haven't gotten there yet. They're advising that you should put one in, but they're not saying you have to have one.
Real quick, Eric.
Yeah.
I can tell you that on the insurance side, since I came from that before, I know quite a few people in that industry. On the insurance side, they are trying to figure something out because, quite honestly, the insurance companies are just tired of paying out lightning strikes on boats. I mean, it happens all over the place. Just like in Florida, it's extremely hard to get flood insurance in a lot of areas. Insurance companies just don't want to do it because you're going to flood, right? They're getting to the point where they don't want to offer lightning strikes. They want to call it, act of God uncovered or whatever. They're trying to get out of it. So although there's not a standard on the boat side to put these in, the insurance company is fighting for a standard on their side to no longer have to cover these lightning strikes. So it's kind of like you're stuck in the middle, Right now it is your insurance's problem. The boat manufacturers go, hey, you don't have to plug your boat in. You don't have to leave it plugged in. You plug it in, charge, unplug it, leave it, you can run your boat that way. You also have to monitor it on the regular, make sure your batteries don't die, all of that. The boat manufacturers at this point with no standard don't see it as their problem. And the insurance companies are trying to stop it from being their problem. That leaves you, the boat owner, in the middle.
Yeah,
So-
always remember insurance companies, they're in business to make money, not lose it. So they always come up with loopholes to try to get out of things. So it's best to cover yourself.
Okay, I have two 30-amp short power circuits, so would I need to get two isolation transformers?
Yeah, I
or
think-
do they make one
I
that
think I've seen there's one that will do, it's one package that does a dual 30s. I have to look it up, but I do believe they do, or they are making one that does that. So basically you'll have one device with your two shore powers coming in, that's all built in one, and then your two legs going out to the boat.
Most of them, though, are single.
Yeah, most of
So
them are.
most of them are. If you have two 30-amp plugs, you need two 30-amp isolation transformers. If you have a 30 and a 50 plug, you need a 30-amp isolation transformer and a 50-amp isolation transformer.
Yeah, that's important right there, is the 30 and the 50, you definitely gotta have.
Yeah, you definitely have to have two.
Yeah.
There are a few units out that will handle two 30s because that's become so common.
Yeah.
There are some units out there that will take two 30s in and give you your two 30s out on the other side. Most of them are individual. For every plug you plug into your boat, you will have one isolation transformer.
So, so the recommendation here, and you're gonna start to find it, like he's talking about the insurance companies, what's gonna happen as they keep paying claims out on lightning strikes, and they're getting tougher and tougher about what they're gonna pay on a lightning strike. We see it a lot now with when we're doing our estimates, because it can get very pricey. I know we had one boat that got totaled from a lightning strike, not because the physical structure of the boat was damaged, but because of the extensive electrical damage to all the systems of the boat. So that stuff adds up quickly. When you add the labor to rewire a boat and all the appliances, all that, it can outvalue the boat pretty quick. And the insurance company say, nope, totaled. So, it's an expensive thing for them, electrical hooks, yeah.
With the strike that occurred here at South, I think there were 8 boats damaged. I think one took a direct hit and the rest were indirect. Were all of those boats plugged in? All the other boats that were?
I believe they were. I believe they were all sharing the shore power system.
They were all plugged in, and I can tell you now, we have confirmation, there were 2 direct hits in that same corner. Yeah, we had, Starlifter was the original one we thought was the direct hit. And now we have confirmed that Eigenvector also took a direct hit. So, yeah, there were 2 boats hit during that same storm, that same day. So,
Were these sailboats or?
both sailboats. Yeah. And look, I know there's the sailboat, powerboat, fight, but we have not had any powerboats affected over here, but we also have very few powerboats over here. We do have some, but, so it's kind of hard to say.
No, it's a sailboats have a stick up.
Both of them took direct hits to the mast. Neither of them have VHF antennas anymore. They evaporated.
Yeah. Yeah, unfortunately, sailboats are lightning rods. They're in a tractor, But these are things that you got to really consider about your electrical system. So the point is, the isolation transformer is a good investment. If you've got a lot of systems on the boat and you want it to function properly and have it work throughout its life, I would highly recommend moving to that direction. Like I said, it's not required. Where you do see them put in is in the larger motor yachts because they have so many voltage systems on there. They're trying to avoid that low voltage issue because of just demand. But you have some other benefits too. So if we have an isolation transformer, I'll give you an interesting one. I had a customer who got their boat surveyed. Didn't realize he had an isolation transformer. The surveyor goes and tests all the outlets in the boat while it's plugged into shore power. And he gets to the GFI outlets in the head and in the galley and writes down not functioning, need to be replaced. Right? So then I got asked to come over to the boat and just check it out because it just seems really odd. He said, I only replaced them a couple of years ago and they can't be bad already. I don't even hardly ever use them. So I get on the boat and I start looking around. Sure enough, I found a galvanic isolation transformer installed in the boat by the manufacturer. He just had to look for it. I guess the surveyor didn't realize. He didn't really take things apart to find it. So, isolation transformer now acts kind of like the GFI.
You can't have 2 GFIs on the same circuit.
Well, they're on separate. One's on the galley circuit, and one is going to be on the head circuit.
You mean because the isolation transformer acts as one?
Yeah.
It acts as one, but not like you're thinking. I know what
Yeah.
you're talking about, where they'll trip because they're on the same. It does because it's not really a GFI. It acts like one,
It acts,
but it doesn't have the same
isolated.
interference of 2 being on the same circuit.
Right.
So you can have the isolation transformer and still have a GFI on that leg, and it's fine. GFI doesn't act the same.
That's right. The GFIs, you'll plug something in, they'll work. It won't trip. So when you do your trip test, it won't function that way. Or if it's got the light indicator on there, it'll show a fault, even though there isn't a fault. Because now we're isolating that. So now we basically, essentially, the whole voltage system on the boat is now protected. So you're isolated from the source on land. Remember, we're treating the isolation transformer as a source. Right. So the shore power is just a way that we're converting that power onto the boat. So the interesting thing there is that, yes, the GFIs do work, they just don't work when it's in shore power mode. Right? So you unplug the boat, run the generator, my GFIs work. Like they're supposed to. Because of the way the grounding system was done for that. So, yeah.
So should they not be installed in the bilge?
The GFIs?
No, the,
Oh, the isolation transformers?
yeah.
No, you don't want to put them in a bilge. You want to put them in an area that's going to remain relatively dry. So usually an engine compartment, a locker, somewhere where it's going to stay dry. But the big thing is you got to have ventilation. It's got to be able to get the heat out. So if it's in a compartment, let's say it's in a stern area, compartment near the shore power plug. If that compartment is there, there must be some ventilation to allow the heat to escape and air to get to it. So those are the two important things that you've got to do, ventilation, and it can't be in a wet environment.
Just real quick to add on to that, because I see it a ton. When we talk about these things and the fact that they need to breathe, what I see a lot is somebody will put something like this in a locker, right, a cockpit locker. And that's great. And they're going, look at all the airspace it has. And then when they're done the project, they throw all the life jackets in there, they put paddles in there, they throw their sail cover in there. And it's like, it doesn't breathe anymore. So remember that if you're putting things, I see a lot of electrical components in lockers, and that's fine. Make sure that you're not then packing them tight, hitting wires, potentially unplugging wires, causing heat issues. So just be aware of that when you consider space to put your electronics.
Yeah, don't. That space got to be able to breathe, so allow it to breathe like it should, and it will function the way it's intended. Yeah. But yeah, no wet. Don't put it in wet spaces. So on the shore power, the other benefit with that isolation transformer again is when we get to the cathodic protection on your boat, your anodes, right? We've talked about this before in some other seminars, but it's always a good thing to reinforce. So when we're connected to the shore power system and we have a bonding system on the boat, which is connected to all of our metal underwater hardware through the ground, right? We're sharing that same circuit with all the boats up and down that dock that are plugged into shore power. So where this becomes a problem, say you have a sailboat with an aluminum sail drive, right? So if you have a sail drive that's got aluminum on there, it's very susceptible to galvanic corrosion because the aluminum is not very noble. It wants to act like an anode, and we don't want it to do that. And we want the anode that we did put on it to do its job to protect it. So if we're plugged in that system, and lo and behold, either side of us, we have two big sport fish boats, big bronze propellers, big bonds, rudders, shafts, struts, got a lot of metal hardware. He puts his anodes on. You keep coming down to the boat, say you have a diver, you get hauled out to check your sail drive, and you're like, what the hell, the anode's not lasting more than a month. It's because your system is acting as the anode for those two sport fish boats because you're plugged into shore power.
You mentioned the strut. Okay, I have anodes on the shaft and on the propeller. There's nothing on the strut, and that's kind of isolated from the shaft because it's got
The rubber.
The rubber.
It should be connected to the bonding system. There should be, where the bolts go through,
Okay.
there should be a green wire coming off of there going back to ground tap that connects all of those circuits together.
So that should cover it then.
Yeah, that should cover it.
Okay.
Yeah. So the one thing to keep in mind, just a little reference on anodes, right? And the reason I call it anodes, not zinc. Zinc is a material we use as an anode, but a lot of times we can use aluminum. We're trying to switch over to aluminum for anodes. It's cheaper, it works actually better, and it's better for the environment. So it's some other things to consider. The aluminum anodes work better.
And there's some issues with boats. I know most of you have fiberglass boats, but like Graham now has an aluminum boat.
Right.
He can't put things on his boat. Well, not directly on his boat.
Yeah, so yeah, if you've got an aluminum hull boat, your anode's going to wind up being aluminum. Believe it or not. Kind of seems counterintuitive, but that's what you're going to use on aluminum boat. And you can over protect it and cause problems. Same with steel, any of that type, and wooden boats. Fiberglass boats, we have to be careful too on the balance. But getting back to the shore power side is, if we unplug the boat, disconnect it from that circuit, so think of the dock with everybody plugged in as we're all on the same circuit, because we're all sharing the same ground. So if we unplug it, we now isolated the boat from that circuit, all right? And now the anode should be doing just its job protecting the metal that it's attached to.
You can get the same benefit just throwing the breaker, right?
No, you're still connected. The breaker does not interrupt the ground. It only interrupts the hot and the neutral.
Okay.
So, yeah, you want to physically disconnect. So that's what the isolation transformer does. So here's the benefit of the isolation transformer. But now we don't have a physical connection on the ground side to shore power, right? So it's separate. So we're completely isolated. So our anodes, and I can tell you from personal experience on the boats that I've worked on that have an isolation transformer, they're in the season, in the water all season. They're being used, they're being plugged in all the time. We haul them out. Typically the anodes are in really good shape, right? They're doing their job for the metal that's on the boat, like they're supposed to. And just another point on anodes, you can put too many on. You can overprotect, and that will create problems. All right, you're going to generate a voltage that you don't want. It's going to become undesirable. There are ways to test to make sure you have the right amount. We do have a tester here at Haven Harbor, and we have our skilled technicians that will be able to test it if you have any question about whether your cathodic protection system is actually working the way it should. It's in the right range. But don't overdo it. Should be only about 2% by volume of material for an anode. So whatever, you know, your shaft weighs and, you know, approximately. But that's what where we want to be. We don't want to go overboard. I see people, they'll add a couple more anodes on their shaft. You know, there's two that are still partially there, so let's say, I'll leave them on there and I'll put two more on. Don't do that. Just take those off, put the two on, and call it a day. All right. So don't try to overprotect. You're not going to help yourself. But physically disconnecting from the dock in some fashion is going to help with that problem. So it's a really good idea. That's another added benefit to isolation transformers. As these boats get more and more complicated with the electrical systems and the more devices we have on them, that's where they become a much more needed item as part of that system. It's definitely something to look at. And getting back to the galvanic isolators, if your boats are equipped with a galvanic isolator, I strongly suggest every couple of years having somebody or yourself test that galvanic isolator and see if it's actually doing its job. It's got a diode in there that prevents voltage from flowing back. And if that diode blows, and it doesn't take much to damage the diode, you can have a near lightning strike that could be on the other side of the harbor here, but it'll be enough to damage that galvanic isolator. These boats that had the lightning strike here, if it were me, I'd probably send out a notice to everybody and say, hey, if you were plugged in at this time, you might want to have your galvanic isolator checked and just make sure it didn't fail because of the strike that we had. So things to consider.
We semi fell down on that. We did. Hopefully everybody here gets the Haven Harbor newsletter. But we did send out a notification when the lightning strike happened saying, hey, this did happen, you should be aware, all of that. And we've talked a lot about the isolation transformer, and you know, I don't want people to get scared. They are large, they take, you know, they have some weight to them, they need space for ventilation. It is your best way of protecting your boat. But there are other options of how you can go about trying to protect your boat. Isolation transformer is if you're plugged in, you're safe, right? That's a guarantee. Because of the cost, the size, all of that, there are other ways you can go about trying to protect yourself that aren't quite as extensive, do give you some other benefits, but we can't stand here and say that they are the same protection, right? What Eric's talking about here is a physical disconnect, and this does it for you electronically, basically. Okay, the isolation transformer does. Another thing to consider, though, when we talk about protecting your boat from shore power, is a lot of people are down on the weekend. You know, they leave their boat plugged in all week long. They leave their boat plugged in when they're not here. That is an entrance to damage, right? So isolation transformer is your safety. You can go with a solar system, okay? You can do a solar system on your boat. It's going to keep your batteries charged up enough with whatever loads you have on, typically your bilge pumps if they run, whatever, to maintain your batteries. When you're not on the boat, you unplug the boat. You don't leave your boat plugged in all week long. Solar panels will keep your batteries charged up enough to keep your main system safe, and you don't have to do an isolation transformer. Now, you leave your boat plugged in, a storm comes through, you need to unplug it, right? You're no longer safe. Still doesn't protect you when you're plugged in from all the other issues of under voltage, all of that. But it is not the only way to protect your boat from a lot of the issues that come along with being plugged into shore power. You know, shore power is great, it's amazing. We plug in, we've got air conditioning, we've got hot water, we've got batteries charged, it's great. Comes with a lot of problems. So one of the big things that I do want to get out there to everybody is we do the seminars and you get some information. You go home and you've got these great little facts and stuff, but you're still kind of lost. Like, how do I decide how I want to proceed? How do I figure out what's the best option for my boat and all of that? One of the big things that I want to impress on people is that just because we're not doing the work on your boat, even if you want to do it yourself, doesn't mean that we're not here to help. Eric's position is technical lead, right? He's got a wealth of knowledge. Taylor, who's our electronics lead, since we're talking about electronics today, has a wealth of knowledge. Now, he runs around crazy all the time. He's got a lot going on. Eric's position is literally knowledge. That's what he does for us, and it's fantastic that we have him. But so do all of you. If you're curious about what would an isolation transformer for my boat cost, right? What size should I do? Where would I put it on my boat? Erik can help you guys look at your boats, plan this stuff. If you want to do a complete electrical charging system and everything on your boat, he can help you design, make sure you have the right equipment spec, make sure you have the right stuff that you need to be successful. Don't just look at us as the people who are going to sell you equipment and install it on your boat. We want to help you too. Because if your boat's safe in our marina's safe. If your boat's a danger out on the dock, it's a risk for us, you know. So use Erik and all of us by all means as a resource. You know, don't just take the seminars as your only spot to get information. If you have further questions about this stuff and how it applies to your boat, talk to Erik. Absolutely, he will help you figure it out. And that's not just for electrical. You have plumbing questions, you have rigging questions, fiberglass questions. Erik can help you out. You know, he'll make sure that you're on the right path. I don't want people to feel like I'm not having Haven Harbor do the work, so I'm kind of on my own. We're here to help you. We're here as a knowledge source for all of you to make your stuff right. Now, if you have questions, Erik is here. If you want Erik to design you a complete electrical system on your boat, he certainly can. He's probably going to charge you for the design time. I'm just being honest. But you don't have to pay us to do the whole system. So as we talk about these things, I know a lot of questions are going to come in your mind. Is an isolation transformer right for me? What is the solar option, you know? How much solar do I need? How many panels? Where would they go? What size charger? Erik can help you figure all of that stuff out to get your boat to wherever you want to be, with whatever system it may be. So just remember, as we talk about the isolation transformer as being your safest way to have shore power and charging, there are other options, and by all means, come talk to us. You know, we're happy to help you figure out what is the protection that fits you and your boat best.
You know, like I said, that's, you know, part of Haven Harbor. We're a service business, right? We're here for you. So we are a resource for you on that leg as well. So always feel free to call, email, either myself, you could email Taylor, Curtis, any one of us, and we'll get that to the right people and get that information for you. So don't feel that you can't reach out to us. Always do. Always feel like you can. All right. I may not answer you at midnight. It may be the next morning. Sorry. But we usually will we will always get back to you and try to help you out as much as we can on that stuff. Now, where he's talking about charging, that's kind of where I'm going next. So we have the shore power system. Do we have any other questions on the shore power connection, isolation transformer? Any other questions there?
Yeah, I think my boat doesn't have a galvanic isolator. Yeah, so if I have one, where should it be located relative to the shore power connection?
Should be somewhere in in line of where that shore power wire connection comes into the boat. So wherever they've mounted it,
Mhm.
it's gonna be in there. Sometimes they'll put it up behind your electrical panel where the main AC shoreline comes in.
Okay.
And it might be behind there, and then off to the branch circuits it goes. So
The
we'll have
key
to look
for it is that it be between your shore power plug on the boat, where your power comes in, and your breaker panel or any other AC electrical device, if it happens to branch off, which hopefully it doesn't. But it needs to be between the shore power plug and any AC device. That needs to be before that.
Okay.
So that's really the key.
It could be behind the panel.
Yep, can be right in the locker where the plug is, can be up by the breaker panel, but it needs to be the first thing the ground sees once it comes in the boat.
Okay, I was assuming that it was going to be near the plug, and I don't remember seeing anything around that area.
Yeah.
So
It
that's
may
why-
not be.
Yeah.
A lot of them
And
are
it-
hidden behind breaker panels.
And it will say galvanic isolator. It'll have, it's gonna have some label on it.
Okay.
All right, so it'll be identified. Yeah.
And will you have two? You have two, you know.
If you have
30
two 30 amp cords coming into your boat, there should be two, one on each leg. So, and that's another thing I want to point out. If you guys, say you buy a boat, doesn't have air conditioning, right? Has an AC system, or as referred to shore power, so you can run outlets and appliances, but you don't have an air conditioning setup, and you need a separate shore power 30 amp. That new installation is going to include a galvanic isolator for that new shore power plug being installed. So don't forget that it's got to be in that circuit as well. So don't, no matter what. The problem is when we have electric motors on boats, the circuit boards, especially electric motors, battery chargers with windings, those things are susceptible to failure. So the windings over time, and I have an expert here to talk a little bit about electric motors, batteries, and some other things. But you'll find out these things wear. The coatings melt off of them. And you get AC leakage from those devices. So my last thing I'm going to talk about with the shore power, AC leakage. Right? So when we talk about AC leakage, that's what's tripping the breakers on the docks with the newer standard. So you plug your boat in, you turn on an appliance, or you just plug it in, the battery charger comes on, and all of a sudden you find the pedestal keeps tripping because it's detecting milliamps of leakage on a device on your boat, most likely. I can guarantee if you go around and check boats 10 years or older, you'll probably find some AC leakage, very minimal, but it's not something we want. We can test your boat for AC leakage. It's a process. We have a meter that we can put on and see what the milliamp leakage is across the shore power connection. And we just basically go through and turn on and off different devices and see what those readings are. And if we see a spike above the well, not really natural, but the lower limit of AC leakage, and we know that device has a problem, and that's what's going to be addressed. But yeah,
Can you speak to the case of where your boat has a crossover switch to connect the two different, for example, you only have one wire, you want to connect or can connect, it's like you want to run your AC as well as your generic AC equipment?
so you're talking about a selector switch?
No, it's just,
Or-
so there's, on my panel, there's a crossover switch. You can either connect to the generator if you had one,
Oh, I
or
got it, yeah.
connect it to the other 30
Yeah,
amp.
so basically that's a power source selector,
Mhm.
right? So we don't want to combine power sources. So if you have a generator, inverter, okay, an inverter is another power source, and shore power, those three things, you have to select which one you want to be on. You'll have a selector switch. So you can't accidentally have shore power and the generator on the same panel, because bad things will happen. You will get over voltage on things, things will trip, things will burn up.
You will release the magic smoke, as we call
Yeah.
it.
So we have the selector switch. So if you have a selector switch that's not being used, you only got one source, on that?
I have two 30-amp inputs,
Right?
and there's a switch that allows me to connect to
It's parallel.
a
It's
generator
probably a
if I
parallel.
had one, or tie into a single 30-amp connection. So everything is then running off the one single 30-amp input.
Yeah, some of the boats have a parallel switch, and you're limited as to what you can run. It doesn't mean you can run parallel over and run all the air conditioners, and run the hot water heater and the coffee pot.
Yeah.
So you
My
have to be
question was
careful.
mostly regarding any complications as far as surging or crossover current issues or whatever.
So as long as the incoming is properly dealt with, whether it be an isolation transformer, whatever route you decide to go, your galvanic isolators even, you have two 30s coming into the boat, you still need two 30-amp galvanic isolators. Once they come through the galvanic isolator, if you're using plug 1 to run just this section, plug 2 to run just this section, or you're combining where plug 1 will run whatever you want in both of these, that doesn't affect any of your safety, any of your issues there. The only issue you run into there is a sticky wicket, and that is where it becomes load management, okay? So without an isolation transformer, right, if you're just running galvanic isolator and solar or whatever you're doing, if you don't have an isolation transformer, the risky part of that is you have 30 amps coming into the boat, you've run your combiner, so you have 130 coming in, it's running both breaker panels. You turn on too much of a load, in theory, what should happen is your 30 amp breaker at the top of your breaker panel should blow. If not, your 30 amp breaker at the shore power should blow. These are all theories of everything's working great. Unfortunately, in the marine world, it doesn't.
What I see more frequently is the breaker on the battery charger that trips out, and that shuts everything down.
So that's because your battery charger is actually not receiving enough power. That's the problem when you have that, is you potentially could be trying to draw 50 amps off of 130 amp cord. And if any of your breakers, your weakest breaker is going to be what's going to go. I mean, that's the reality. Not all breakers are exactly whatever. Your weakest breaker is going to be the one to go. It's going to try to dump a load somewhere, whether it be a main breaker, an individual circuit breaker. The only risk you have there is the overcurrent draw, because when you have 120 volts at 30 amps, you try to pull 50 amps off of it, it has to give somewhere. And the way it works in electricity is 120 volts now becomes, like Erik said, 90 volts. Right? So everything is pulling power and it's turning on, but it's not running to its best potential. It's not doing like it should, and every single circuit board that has power to it right now is at risk because it's being underpowered. So you have a situation on your boat where you have to consciously do load management. As far as risk of anything otherwise, you're fine. The only only added risk you have is making sure that whatever breakers you have on, you're not pulling more than your total 30 amps that you have. Doesn't put you at any more risk than that.
Yeah, just always remember with voltages, if you're trying to run something on lower voltage, the amperage is going to go up. Right, so that's going to start tripping things. But at least it should, if it's working like it's intended. Any other questions there? So, just to recap, the AC leak testing is something that you probably should look into every once in a while and just check to make sure the appliances on the boat are operating properly. Just because you have AC leakage doesn't mean necessarily it'll trip something all the time or be a problem, but it can be down the road. I can guarantee I could go out in the summertime here on any boat, usually over 10 years, put AC leakage test on there and start to see that it's starting to leak more milliamps than it should for that boat. So it is something to consider.
Another sign that sometimes happens, it's not a guarantee, it's a fluke that happens in the electrical world, but another sign that you may have some leakage or something going on is if you've ever plugged into shore power and when you turn on a bunch of loads, you see your reverse polarity light come on real dim or start flickering, right? You got a problem.
Yeah, that's a good indication that there's something going on that needs to be looked at. All right, guys. So a little something I wanted to just talk about How many of you here have solar panels on their boat? Okay, how many here have wind generators? Excellent. You got the best of both
He's
worlds.
ready to go.
So, just so you guys have an idea about solar panel. So if you've got the 12-volt systems on your boat and you're trying to keep, like Curtis was referring to, and you want to keep your batteries topped off, and you can, that way you can remain unplugged from shore power if need be, or if you're on anchor. You know, that's a good way to go. We get a fair amount of sun, and especially here in the summer, we get long days of sun, so they work. Does everybody know how efficient solar panels are at creating voltage or current?
At our mark here, because it changes where you are on the earth, but our mark here, we're somewhere about 40%.
Well, 40% of gain.
Efficiency, yeah.
So solar panels themselves are only up in the height, well, mid 20% efficient. I mean, that's just the threshold right now, the technology that we have for solar panels. Wind power, does anybody have an idea how efficient wind power is? 60 to 90%. That's as long as you have wind, right? So that's a little problem we have here on the bay sometimes. We don't get a lot of wind. You know, so if you're in an area that has prevailing breezes, wind power is probably a good way to charge your batteries because you're going to get 60 to 90% efficiency out of the wind power. Right? So some things to consider when you're looking at charging devices on your boat. What's going to work best for where you are and how you're using it?
Getting both up.
He's good to go. Yeah, he's ready to go around the world now.
So does that mean, like, if you have 200 watts of solar capacity and it's 25% efficient, you're only really drawing 50 watts? Is that what you're saying?
No, the maximum that it can produce is just that the energy being transmitted from the sun to the panel and being converted over is only about 20%. Wind power is 60 to 90%. So the wind driving that winding to develop power, you're getting a much higher efficiency. That's why the wind industry generation, that's why you see the windmills and all that industry taking off, because it generates much more efficient power. Solar is great, but there's some limitations. We almost need a combination of the two, especially here on the bay.
The two numbers that get confusing there are the two different efficiencies. So the efficiency that Eric's talking about, the 20%, if we could literally measure the sun coming down on the boat, right? It takes 1,000 watts of sunlight for this panel to be able to make 200 watts, right? That's the energy he's talking about the 20% efficiency, right?
Yep.
It takes 1,000 watts of sunlight to actually let this panel make 200 watts, okay? That's built into the manufacturer. So when you buy a 100 watt panel, its maximum output is 100 watts. They've already calculated in this 20% efficiency, correct?
Yep.
What you do need to be aware of on your solar panels is that here, where we are, we're about 40% efficient on our solar panels. And that is due to where we are on the earth. As you go down to the equator, your 100 watt solar panel on a clear, no clouds day can produce 100 watts. Here, on a clear, no clouds day, your solar panel can only produce about 40 to 60 watts at best, okay? And that's just because of where we're located on the earth. So when you calculate your solar power for what you're gonna do, to grab two 100 watt panels and throw them on your boat and go, I got 200 watts of power. In theory you do. You're never gonna get it here, right? That's at the equator. So there's two different efficiencies. The one the manufacturer's taking care of for you. If you buy a 100 watt panel on the equator on a clear day, you got 100 watts. Here, we're only getting 40 to 60% efficiency. So you have to remember that in. Here, you would need more solar panels to give you the same power on your boat. Does that make a little more sense?
Yeah.
Okay.
So the part I'm getting to here is that we have choices for generation for these systems. So, you know, you want to decide, is wind the way I want to go, solar, or is it both? So these things are what you want to try to figure out. What's going to work best for your situation. So if you're going to unplug the boat or it's going to be on a mooring, you know, these are considerations that you want to make.
Oh,
Yeah,
sorry,
but-
real quick, and as you go north, if you're someone who likes to go north, don't forget with your solar panels, as you go north, it gets worse. So if you're going north, you definitely need a combo of solar and wind.
So, so the old story of what's better, solar or wind, it depends. Depends on, if you're in a very cloudy climate, solar's not gonna work so well, but if it's cloudy, it's probably windy. So the wind is gonna be the better one. The other part of generation on the boat is a generator, right? So how many here have a generator in their boat? So you use that to power your AC systems that are on the boat, air conditioning, your appliances, whatever it might be, battery charger, right? How many do you know, are you producing more or less power than what's required to run those systems on the boat?
Yes.
Less? So there's a couple things we want to consider. If you're going to consider putting in a generator, right, you want to size the generator properly for the systems on the boat. I hate to say this, but I've got people that will come to us and say, I want to put a generator in the boat because I'm going to put air conditioners in it, a couple of years, but I'll just use it to charge my batteries and plug in my coffee pot. So if I figure out the generator to run all of those systems, even though he doesn't have the other higher draw systems, that generator is never going to run to its proper load. It's going to be hard on the generator. We're going to shorten the life of the generator. So the important thing to consider when you're doing a generator installation, that you're getting a generator that is close to the limit of what you need so that you load the generator properly. Oversizing the generator is not a good idea. You want to be sized in that sweet spot, whatever that percentage by the manufacturer gives you of your maximum load. So keep that in mind. Don't decide I'm going to put a 10 kW in here because I'm planning on down the road, but you're only running 5 kW worth of electric on the boat. The generator wants to be loaded up for it to work right. So sizing generators is an important part. So if you get into that situation, that's something you need to consider. If you're doing the generator and you want it for air conditioners, you're going to need to do the air conditioners at the same time. Get everything matched up.
Or at least purchase the air conditioners. You may not be ready to put them in yet until next year, but purchase them so you know what your load of your compressor is, of your pump to run your raw water through your air conditioning system. We have to calculate all of those loads when we try to size a generator. So if you buy the generator now thinking you're getting this air conditioner, and in 2 years that air conditioner is no longer made, you may be in problems now with trying to figure out your loads that are going to work with the generator you have. So you just kind of need to have the whole plan in place when you spec it.
So another question I have for you, how many of you here have a portable generator that you use on a boat?
That's what I'm thinking about.
Consider.
All right,
Consider.
don't consider it. And I'm going to tell you why. So if you're thinking about going out and buying that little Honda generator, you're going to put it in the cockpit. I've even seen people put it out in their life raft or in their dinghy out behind the boat, thinking they're being safe, right? That little portable generator is not designed to code for our standards for operating on a boat or driving our systems. It is not wired correctly for it. You will have, if you're using a gas, it's most likely going to be a gas one. So now we have poisonous fumes. We're operating on the boat. Something happens and it catches on fire because we've got a gasoline fuel source on it. Fuel line leaks, sprays on the hot exhaust, poof, you got a fire. You got it in your cockpit, burn your boat down. I can tell you what's going to happen. Your insurance isn't going to cover you. That surveyor comes down and found out you had a portable generator on there, that you're operating the cockpit and had a boat fire. You are not covered. Because it is not to standard. It is not part of that boat equipment. So don't do the portable generator on the boat. You need to have a generator that's installed and meant to be on a boat. That's the code. I see this a lot. Summertime, out here on the bay, I'll see a guy with a small cabin cruiser, and he's got the little Honda sitting on the swim platform running about that far away from the water. got his cord plugged into it, runs the cord into the boat, or he has an adapter, runs it into his 30-amp shore power. Not a good idea. It's not intended for that purpose. All right.
And just a quick note on that, they also won't last super long, just so you know. Again, as we talk about tinned wires and all of that and your marine wire, well, marine generators, same thing. They have copper components inside of them, and a lot of those copper components are tinned. And a portable generator, they're not. They're not meant to be in a saltwater environment. So literally, your coils and everything inside the generator are just getting eaten alive as well. And that'll cause you bad power, potentially fry circuits on your boat. It's really not a good idea.
This is a case where resistance is not our friend. Anytime we get corrosion, we get resistance, produces heat, low voltage, bad things happen. So just keep that in mind. But yeah, no portable generators, sorry. You want to have one that's installed in the boat, that's an actual marine regulated generator. So. The other thing about generators, where do we put them in? What's that?
There's a question back there.
Doesn't a marine generator ramp up and down its power depending on demand?
Yes, it does. But the problem with the generator, the motor, it wants to run closer to its load rating. It doesn't like running at idle speeds or hunting up and down because of the lower loads.
Okay.
It's very similar. It's very similar to a car. If you've ever heard you're not supposed to idle your car for a very long time, and you go, well, why not? I mean, my engine runs all the time. They're just not meant to do that. They're meant to push exhaust out. You know, they're meant to have a load on them. They can run a tiny little load basically at idle. They're not. The engines don't like it. They're not designed for it. They're not clearing out their systems. They're not scavenging exhaust and fuel out of the engine like they're supposed to. Yeah. It's just hard on the whole generator. So that's why you don't want to do it.
It's going to shorten the life of it. And you're going to have service problems. You know, you're going to have issues with the exhaust valve. I see exhaust valves on the smaller generators that wind up burning out, getting stuck, moisture because the exhaust isn't running up enough. You're not getting enough back pressure out of it.
You're not burning off the carbon either. So
No.
they get built up with carbon and they get sticky. And
So the other, sorry.
Just quickly, on the load on the generator, let's just say you have your air conditioning, your refrigerator, your normal load with the air conditioning going. I mean, the air conditioner, of course, is going to be cutting on and cutting off.
Right.
So, is there, I mean, how do you figure, how would you fudge
That's going to be an average. And it's
Okay.
going to be an average towards the higher rating.
Because the air conditioner is going to be the largest load,
Right.
but it's not going to continually run.
Right. Yeah.
Is there a percentage that you look for? Or?
Not really a percentage. We just want to make sure that whatever the devices that we're putting on the boat and our generator rating is as close as possible to that demand of that load.
when you dive deep into the manufacturer specs, the manufacturer gives you a range of what that generator wants. It's a 5 kW generator, right?
Right.
But they give you a range of what that generator really wants to run at. It doesn't want to run at 1 kW. You know, it wants to run 2.5 and up.
Okay.
So we know that you're not going to be running at 4.5 the whole time, but we don't want you running way down here at 1 either.
Yeah.
So we find that average, and every manufacturer, when you dive into the specs on their generators, they give you a range of what the generator wants to run.
Cool.
Yeah.
So the wear you're talking about is on the engine, not the generator?
No, an actual separate generator. We're not talking about.
No, I understand, but the wear to the generator unit, you're talking about wear to the engine?
Yeah.
The engine in the generator.
Driving that.
Yes. Yes.
Because that's got to drive that system, and it's looking for load. Those engines want to get to their rating.
Higher RPM.
Right. When they're at the lower RPMs, it's hard on. So that's where the maintenance becomes a problem. Now, for you, those of you who come down, maybe you don't use a generator very often on your boat. Maybe it's once or twice a year out on the bay. Most of the time you're at a slip or at a marina, and you think, I'll go over here, and generators are running well, I'll run it for 5 minutes and make sure it starts and works. Don't just run it for 5 minutes. Put a load on it. Shut the shore power off, turn everything on, have that generator run under load at least a half hour. Let it get to temperature and do its job. So that's how you're going to exercise it. Just a 5-minute start run, shut down. That thing's not getting the temperature. It's not putting the load out. It's not good for it. That's gonna shorten the life of your generator.
The thermostat in the generator may not even open.
Yeah,
And
exactly.
you don't realize that your thermostat's stuck, so then when you go out on the water, you're overheating your generator.
So, use the generator, make sure that you're putting a load on it, make sure it's designed for the load that you have on the boat. So these are all things you want to consider and things you want to do in order to maintain it.
You're at 10:30, just
Yep.
FYI.
So, we're gonna do our coffee break, stretch your legs. When we get back, in about 10 minutes, we're gonna do a raffle. We got a grand prize, and then we have some fun gifts. And then I'm gonna have Nick Slater is gonna come up. We'll start writing out a little bit about alternators, and then we're gonna get into the battery side of things. All right, guys? Here, he's gonna talk about alternators, some of the battery technology, and then Curtis and I are gonna follow up and talk a little bit more about the new lithium battery technology that's out there, and why we should start considering doing lithium batteries on boats. There's been some changes just in a few years on the technology that's getting to the point now where it's starting to make a lot of sense. So we'll go over some of that stuff. So with further ado, come on up, Nick.
Thanks. I'm just gonna bring Chris up with me. Chris is my partner. We have, I don't know, 25 years of experience doing starters, valve thrusters, alternators, regulators, batteries, battery banks. We have a company now that supports large high energy stationary power projects. Being in Annapolis, we get used a lot by the sailboat community. But mostly our bread and butter is supporting large marinas like Erik's place here at Haven Harbor. We just got done getting contracted for the last 2 years by a company down in Pensacola, Florida called Arco. Who got into the high energy regulator and alternator industry. We helped them beta, engineer, and take their product to market last year, which was a high output regulator. And we're about to launch their high output alternator line along with some shunts. And we've also been contracted by many battery manufacturers to tell them what they need to work on over the last several years. We're local guys, we're from the shore. Chris lives in Ocean City right now. I used to live on the shore quite a bit. I live up in Ellicott City now, so we're all pretty local. We saw a need for a regulator recently, and a lot of this that we're going to talk about, like we can go down rabbit holes. So if you guys have any questions, same thing with Erik. Like by all means, like stop the conversation and ask a question, because everything in the marine industry is custom. It's custom, and we want to get you redundant and efficient as possible. Because why do you want to spend all this money on a race car and drive it like a minivan? Like it's pointless. So let's talk about the regulation. Does anybody have any alternators in your boat currently that are externally smart regulated? Does anybody
Here have a Balmar regulator in their engine compartment or somewhere that they're using? Because that's what those are.
Yep. And the point of the smart regulator is to dial in your battery bank to make it efficient so you don't cook it or overuse it. I recommend a smart regulator on just about every system that has, if you're 12 volt, 400 amp hours or more, it really helps you extend the life of your batteries, your charging system. Since everything is pretty much closed circuit, if you have a alternator that is overcharging and producing more amps, the batteries are then receiving more amps, and amps produce heat, so everything's getting hotter, everything's wearing out much quicker. Same thing with your starting circuit. If you have batteries that are not fully charged trying to start a engine, and your starter is drawing more amps, everything will wear out prematurely. So we want to make sure that your battery bank is properly protected with an alternator smart regulator. If you have an alternator and you'd like to not, man, how do I say this? Everything's so loaded. If you have, it is, everything's so custom. If you have an alternator, if you want to buy a high output alternator, like they're expensive, you know, like, and you might not need it if you're a weekend warrior, if you only take your boat out a few weeks a year. But if you're going to do an intercoastal cruise or you're going to go down to the Caribbean, you know, it's almost a necessity. Does anybody have any questions about high output alternators before I just keep rambling on? Because everything is pretty much going to be custom to your boat.
How do you define a high output alternator?
Great. So typically an old external fan alternator that has a fan on the outside that's rated for, let's just say 100 amps and that has an internal regulator will typically do a half of its rated output at idle. High output alternators are typically internally regulated, have internal fans, typically have internal fans. They have a fan in the front and a fan in the back that sucks air in from behind and sucks air in from the front, and all the heat is dissipated in the middle. And high output alternators will typically do, if you have a 100 amp alternator, it'll typically do close to 100 amps, predominantly at idle, for an extended period of time before it overheats. That's the best way to define a high output alternator. But in this footprint right here, this is kind of a small to mid-case alternator. Like this is 20, 25 years ago, if you have an old Yanmar engine, you got a Hitachi alternator on that thing. Your old Hitachi alternator will do about 70 amps this size. This thing that we're going to launch this year is good for about 180 amps at about 3,000 RPMs and about 150 at idle.
Does everybody understand, sorry to interrupt, does everybody understand the benefit of the high output alternator for you? Yeah. Okay, so, sorry to interrupt you real quick. So one of the cool things about a high output alternator is, let's say you've been on the hook, right, for a couple of days, or even a day, it all depends on your battery banks. Or let's say that you're doing a long sail or something like that, right, and you don't have a generator, especially for people who don't have generators. What you can do is you can start your engine, let your engine run, and a high output alternator will charge up your house batteries, your engine battery, your generator battery, however you have it set up, very quickly, okay? Part of that does depend on the battery technology you're using, but the advantage is this alternator can run all of your sailing lights, it can run your bilge pumps, it can run all of that stuff, basically off the alternator before you even draw anything off your batteries. And it is so high output, it can run all of that and charge your batteries at the same time. So now you don't have a generator, but you can keep your house batteries and everything charged up. They start to get low, you run your engine. This high output alternator is going to charge those batteries up pretty quick for you. Whereas with a standard alternator, if you're still running stuff on the boat, you're still sailing, and your standard alternator is running, basically running your boat, you're getting 5 to 10 amps of charge over actually into your batteries, which isn't much. It takes a very long time to get those batteries to charge back up. So high output alternator allows you to extend your stay on the hook by running your engine just a little while. It allows you to extend your sail without having to get some other type of charging or power source outside of it. So the high output alternator literally extends your usage of your boat. So it's a big deal. If you don't plan on just being dock to dock and you want to actually go out and do some sailing or stay on the hook for a while, high output alternator is a quick, easy way to give you some charging without having to be at a dock.
Correct me if I'm wrong though, but I have AGM batteries for my house bank.
Mm-hmm.
Don't they charge relatively quickly up to about 90% of charge, and then that last 10% takes like forever?
So it depends on where we're at on technology with batteries, okay? So we have 3 technologies that are pretty common in our industry. We have lead acid, which are your wets. We have your AGMs, and now we're dealing with lithium ion, lithium phosphate. It all depends on what the manufacturer's using, but lithium batteries, okay? So that's why I said it depends on your chemistry. Lithium ion batteries, which we're going to talk about here in a little bit, offer a lot more benefits than just the weight and the energy storage capacity of it, okay? So a typical lead acid battery
you're kind of charging the lead acid battery at, 3 amps, let's say. Okay, that's the maximum per cell that battery can pull in of charge at any given time is 3 amps. An AGM can take more, and a lithium ion can take a whole lot, right? So whereas like a lead acid battery would take, to get 10, well, it would put the same alternator basically would be able to charge this at 3 amps if we're using those numbers. It would be able to charge a lithium ion at 10 amps. So basically this battery will accept power more than 3 times as fast coming into it as this battery will. So if I have a high output alternator and I'm running lots of loads on my boat and charging my batteries, that's great. If I'm not running a lot of loads, my battery chemistry still limits how fast I can charge a little bit, okay? So high output alternators definitely benefit more with AGM and even more with lithium ion. Lithium ion batteries can charge up so fast, it's ridiculous. We did a big Amel out here, and he did a lithium ion setup and whatnot. He could run his engine for an hour and take his batteries from 10% to 95%, just running his engine for an hour with a high output alternator and a lithium ion system. So you can charge a whole lot faster, whereas with a standard wet battery, you might need to run your engine for 4 or 5 hours to try to charge them up that much. So you've saved gas, you've saved time. So, but it all does, again, this is why you need people like these gentlemen with their knowledge, people like Erik. When you say, hey, I want to do a high output alternator, Taylor too, they will start asking you questions that seem weird, like, okay, what batteries do you have? What systems do you have on your boat? You need to look at the whole picture of your entire power usage and charging to figure out your benefit. Put a huge high output alternator on your boat. You don't have a lot of loads and you have wet batteries, it's not going to do much for you.
Yeah. Like Nick was saying,
It's got to be a thought out system. And that's why everything is so custom.
Yeah.
You have a different battery than he does, the same boat, but wait a minute, he has the same boat too, and he has the same batteries, but he has a different charger on his boat. Every bit of that impacts what you're doing for your whole charging system.
there's no cookie cutter to this when it comes to this side of the industry.
Like you just said something earlier, like I have AGMs. Like that question to me is like let me qualify this guy for 45 more minutes with the questions.
Yes.
Like this battery right here, like this is an East Penn manufacturing battery made up in Reading, Pennsylvania, just north of Reading, Pennsylvania. This is a standard AGM battery. They private brand 50 to 60. Yep, 50 to 60 private brands. They do your Napas, they do your Diehards, they do Federated, Duracell, and even though they're manufactured up in Reading, Pennsylvania, like they're not. Like 50% of their market, 50% of their product line is globally sourced, Mexico, China, because they're a huge company. And their lead oxide paste, which is the material that transitions from the negative to positive plate and then back again during the charging process, is very minimal. So they don't have a lot of lead oxide paste in their battery. So if you discharge this battery below 50% multiple times, you'll hurt that battery over the extended period of time that battery says it will last. And this battery typically is about a 700 cycle battery at a 50% discharge. So, and its charge rate is about C.10. Does everybody know what a charge rate is? That means this thing, if this thing was 100 amps, like that blue battery right there, if it was 100 amps, it can take comfortably 10 amps over an hour, comfortably. And obviously, the more you hook up in a parallel connection, positive, positive to positive, that number goes up a little bit more. There's other batteries out there that are mil-spec batteries. What does that mean? That means the military will buy that battery sight unseen. There's no testing involved in that battery. Two brands that come to mind right now are Concord, which is the manufacturer in California that owns Lifeline batteries, which is a good battery, and Odyssey, which is owned by Enersys, also in Reading, Pennsylvania, which is your red battery, and they just bought North Star. Like that battery has a lot more lead oxide paste in there, so you can discharge that battery a lot further down the road than an East Penn battery, and you can bring it up and it can take more heat, so it can take more amps, more heat, it can charge faster. And that battery, since it's a pure lead battery, not recycled lead, and that's another sales pitch you have to be mindful of, like that battery is a positive state of charge battery, where you don't have to top that battery off to use it a lot of the times, and that's an AGM battery. So think of that battery from Odyssey, or Lifeline, whether it's a starting or a deep cycle or a dual purpose, or this battery, which is an East Penn battery, or a Discover battery, or a Willard battery, or a Dakar battery. That's another misconception. People think there are 5 or 6 battery manufacturers that make everybody's battery. There's not. There's like 500 out there. I know. I've been to most of the factories. I speak Mandarin, ni hao. You know, like I'm not kidding. Like, it's such a smoke and mirror sales pitch out there for a box of chemical energy. Like, and you really have to dial it in. Like, what are you trying to accomplish? How much do you have on your boat? When it comes to a draw, are you running DC air conditioning now? Or are you running a genset? How big is your inverter charger? Are you running 48 volts? Because we're rocking 48 volt systems left and right now. Why would you do that? That's another rabbit hole question. Like it's.
You got a question?
Yeah, shoot.
What is AGM technology? I'm
it's
not familiar with it.
It just stands for Absorb Glass Mat. It's a technology.
So instead of
Yes.
Don't take it out of the bag, but that's
So a normal battery wouldn't have its pads in there, and it would, your solution is gonna be moving around in there. This absorbs it, so the absorb glass mat, keeps it against the plate so it transfers right back and forth.
It's also why your AGM batteries can be mounted in all those different positions, because that mat is holding that fluid on the plates, whereas with a wet cell, the top plates are now dry. That's a no-no, right? AGM batteries can be mounted in any position because of this glass matting that's between the plates.
You lose a lot of energy when that battery is a wet cell gas. They all gas. And this battery, they say they're sealed, although they have vents that will open up when pressure hits at a certain point. Like these AGM batteries, all the gases get recombined in the chemical reaction that creates your cycle, your energy discharge and recharge. So they're more efficient. But once again, like who's making the battery? What are they designing it to do? I'll give you an example. The best battery ever made that nobody ever thinks about was back in the early 90s and late 80s, AC Delco's car batteries. Yeah, dude, like, and truck batteries. Like, those things.
Green eye ones?
Way before that.
Okay.
But here's why. Like AC Delco would, that's when they controlled their own manufacturing, would put like an obscene amount of lead oxide paste in their batteries. Like, so you could never discharge the battery and kill it. Like you could take it down to 0% and charge it back up again, 0%, charge it back up again 1,000,000 times because they had so much lead oxide paste. That's the chemical material that transitions. And that's very expensive. The cost of the manufacturers to put an inordinate amount of lead oxide paste in their battery per application, like, nobody does that. And one person does that. J.D. Surratt at Rolls Surratt up in Canada. He still does it, but he's like the last one. So like, so like what AGM batteries are we rocking? You know, that's like, I'm at the tip of the iceberg right now. Like that's a good question. You know what I mean? Like, that's a good question. These lithium batteries too, and this is something I want to help everybody always understand. Everything's custom. Like these lithium batteries, like they, how do I not go down a rabbit hole? Like there's questions you got to ask too of what you're trying to accomplish. Like you got to almost have a 50, and we have this, a 50 bullet point checklist of what you're trying to accomplish to really dial in a battery, let alone a lithium battery, a battery for your system. Like, and I don't want to, I'm pretty sure you guys are going to cover all this lithium stuff here in a second, but like, you know, does your lithium battery have, and then by the way, like lithium battery upgrades are baller. Everybody should do them. Like if you want to do something, definitely, like, they're awesome. So we've got probably 10,000 stationary power projects, let alone yachts. Typically we do a world cruising yacht, powerboat and sailboat for lithium battery technology. So like we have a ton of them out there right now. But but like, does your lithium battery offer global support? You guys are sailboaters. I think most of you are actually sailboaters. Or does it offer regional support? Does it offer national support? Like, there are some brands of lithium battery you can buy right now, made by some 3-year-old smoking a cigarette in Shenzhen, China, shipping it over here in a container and letting it sit for 3 years at a port, that are really cheap. And if you break them apart and you look inside of them, you know, they got nickel-plated tape that are making all your connections and contact points, as opposed to a copper brass plate with mechanical connections. I mean, that's
So Eric, Eric has an interesting one.
I'll bring up an interesting one. So, a friend of mine that runs a marina out in San Diego had a customer that balked at the price of replacing AGM batteries in his motor yacht. And he had several of them. And the customer went online, and I think he said his customer found it through eBay. A company that had an AGM battery that was, instead of being $240 for a battery that size, it was $160. So, ooh, good deal. So my buddy said, well, you buy and supply your own parts, you know, no warranty. I'm not gonna warranty that whatever gets put in there. So the customer bought the batteries, put them in the boat. They lasted, I think he said it was about a month. So they took the batteries out. The customer wound up buying all new batteries again through my buddy's marina. They put them in. And my buddy was looking at the battery. And the case looks just like that. And he was curious, so they cut the lid off of it. There was a motorcycle battery in the center. Concrete filled the rest of the capacity. 2 small 8-gauge wires soldered and welded up to the posts inside of that battery. So, the moral of it, what's that?
I'd be infuriated.
Yeah.
Infuriated.
So, unfortunately, what seemed like a good deal on eBay to buy these batteries was a scam. And they came from China, and they looked official. When you got the batteries, they were sealed up, looked like that. They felt like the right weight and everything, but they weren't. So like Nick is saying, is you got to be really careful, do the research, make sure the batteries that you're getting are a good quality and some that you're going to be able to get support on.
They should have a big website. They should have a phone number that you can call the manufacturer on their website. If they're only offering email, text support, and there's no phone number on there, they're probably not really there.
I don't like to throw companies under the bus, but in a previous life, you know, Chris and I were responsible for buying, you know, 7-figure POs every month for batteries, and we would buy them out of South Africa from a company called Dakar or Colombia, Ecuador, Willard, and like Liège, and like we got burnt so many times. Like we could buy a Group 31 marine grade AGM battery for like $60, sell it for $300, make a killing when you offer you a 10-year warranty because we'd have 2 warranties covered in the initial sale. Like just, it wasn't something I was proud of, but we tried it. Like
honesty's good.
And in a previous life, and like you know, because we've got to try things. Like there's not a lot of money selling really good batteries, because really good batteries, you know, they charge massive distributors and technical distribution, you know, a lot of money for, and there's not a lot of room for a distributor to an end user. Like the end users, you guys typically will get about the same price for a really good battery as a distributor will. So like, you know, like just buyer beware, and if you don't know, like talk to a guy like Erik. I mean, Erik and I go back probably 15 years now. Yeah, we're good friends. I consider Erik a friend. Like it's so you just buyer beware, and then too, like also like there's flooded batteries out there. Not to throw you guys another curveball, a wet cell flooded battery. There's flooded batteries out there that will give you. Remember I said this one's about 700 cycles at a 50% discharge. That's about the standard life cycle. Like there's flooded lead acid batteries out there that will give you 12, 13, 14, 1500 cycles at an 80% discharge. There's a little bit more high maintenance. But that's not your standard flooded lead acid battery. Your standard flooded lead acid battery is typically 5, 6, 700 cycles at a 50% discharge with some maintenance every year. Like that's standard.
Yeah,
So like Go ahead.
You know, just one point I would make about maintenance on wet cell batteries. How many here do have wet cell batteries in their boat? Okay, so at least every year I ask that question and I see fewer hands, so that means people are switching. So wet cell batteries, how many here went out and bought what's called a maintenance-free wet cell battery?
Well, if you mean it has no caps, yes.
Oh, yes, exactly right. No caps.
They're not,
But
yeah.
it does have a cap. You can rip the whole
Yeah, they're not maintenance free.
a big cap.
They're not maintenance-free. All they are is that cap is designed to help the gassing to recollect the water and put it back in, but it still vents. So it still loses that liquid over time. So what we call maintenance-free batteries are not truly maintenance-free. So be careful about the wet cells. When you see, oh, it says maintenance-free, I'm gonna get that one. You're probably not saving yourself any trouble. They're gonna need to be checked.
And just a real quick safety on everybody that has wet cells. Just remember that, you know, charging your batteries with wet cell batteries, your battery compartment needs to be ventilated and not into the bedroom that you're sleeping in, okay? If your wet cell batteries are somehow inside your boat, which a lot are, you need to be aware that they do off gas when you're charging them, especially when you're charging them with a lot of current. You know, if they've been depleted and you're bringing them back up, they off gas quite a bit. It's not healthy for you. AGMs, like he said, they pretty much try to recycle it as best as possible. The maintenance frees actually do a pretty good job of trying to recycle a lot of the gases. Lithium ions are complete. There's no vent at all in those, is there? In a lithium ion?
No, there's no.
They're completely
different
sealed.
chemistry,
Yeah. So you don't have the off gas in there, but charging your batteries in your boat, you need to be aware that there are gases in the boat being released simply by being charged.
So in the living spaces, there is a standard in our industry, ABYC. We don't put lead acid batteries in living spaces unless it's in a sealed compartment that is ventilated
To the outside
of the boat. So we don't put them underneath the sleeping berth, underneath the pilot seat or something like that, and just put it in a box, a plastic box. That's not vented, right? That's going to spill gas into the cabin. We need to. You can put it in the engine room where you've got a blower and the engine room is sealed from the living space and it's vented that way. But you'll want to make sure you make those considerations. The other thing too, I just want to make sure, how many here have ever tested their own batteries? Tested the condition? What type of tester did you use?
Load tester.
A load tester? So we don't do that anymore. And there's a good reason for that. What happens if we load test a shorted cell or a bad lead acid battery? Anybody have an idea?
Well, here's the catch-22, just real quick here. They're selling the new digital ones and calling them load testers.
Yeah.
So they may think that they're using a load tester. A carbon disc load tester. It's a big box. It generates tons of heat when you test a battery. Those are dangerous.
Yeah.
They're causing fires. They're bad.
Yeah, you want to use the new version.
It's digital.
Which is a digital. It's basically, how would be the best way to describe it?
Man, oh God.
I mean, it literally is software and...
It's basically, it looks like a multimeter. To you, the end user, it looks like a multimeter. And by sending voltages through the battery, different voltages at different frequencies, etc., it can tell the cells. We don't need to get into the weeds, but it can tell the condition of the cells in the batteries. So it's simple. It uses very low current to do it. It's safe for the battery. It's safe for the user. So...
Can I go down a little rabbit hole with that, which is why I said, oh God, oh God. Like, the algorithms that the software companies make that sell to the battery testing manufacturers that make a battery tester and distribute it, the algorithms, most of them, which is why everything is a smoke and mirror sales pitch to get your dollar, right? The algorithm is designed to shoot through the top 1% of the battery plates. Not all the testers, some testers. So like you could cut a battery in half horizontally, put an electric tester on it, and the battery will pass the test, sometimes, depending on the tester. And carbon pile load testers are super dangerous too, in the wrong hands. 100%. Like 100%.
It's okay for techs and labs.
If you're a technician, that's the answer. And
Yes.
Then, and then two, like if you're three, if you're a military spec battery, and your battery is really robust internally, and it's really well built, it has very little impedance. It's got a lot of lead oxide base, it's got really thick plates, it's really well constructed, it's got flat welds as opposed to pinch welds. Internally, pinch welds become porous over time because amps got to go through them. That's where your short happens in a battery. Like, if you have a battery that's really well built, and you use an electric tester on there, and you're in Guam, or you're in Virgin Gorda, or you're out in Portland, Maine, and you call up Lifeline, and you call up Odyssey, and they go, hey man, I just used an electric tester, this battery ain't no good. They're not going to help you because you're not allowed to use an electric tester on the batteries because the electric tester's algorithm from all these different software companies that sell to all these manufacturers that make testers is designed to fail for shitty batteries. How's it going to work on a really good, well-made, constructed military-grade battery? So you've got to hit it with a carbon pile load tester. And then that's tricky too, because taking you down a fifth road, you can't load test a battery until that battery is fully charged. Get an appropriate reading off the load. You want to hit it with, 3 to 4 times rated battery amperage. If you're at 1,000 amps, you want to hit it with 300-400 amps for 10-15 seconds to see if it holds. So like to get somebody to do that, that's in a bind, whose power supply just failed, on a sailboat, out in the middle of nowhere, hey, you got to charge your batteries back up, and then you got to have a nice carbon pile load tester. And those things are expensive. They're $400, $500, $600.
And typically not lightway.
Yeah.
And
No.
they're typically not super portable.
And we live in an area where, one, we have no technicians that are young anymore, so no one's, and convenience is everywhere, so everybody reverts back to a real cheap electrical tester to test the biggest and baddest battery banks in the marine industry right now, which is ass backwards. So like all that needs to be taken into account, testing a battery. Like,
And lithium ions get even more because most lithium ions actually have electronics between the posts and the battery, and you're not even really testing the battery. They're fluky. A real battery test on your batteries is not a 30-minute test. It takes some time, and every battery on your boat has to be disconnected and tested individually and separately. It can't be tested as a bank. So if you've got 5 batteries in the bank, that's 5 batteries that have to be disconnected, fully charged, completely tested properly, reinstalled. It's a project.
there's some really nice electric testers out there right now, and I'm pretty sure Haven Harbor probably has them. This is my first time down to the South area. I didn't even know there was a South Haven Harbor. It's pretty nice. I'm pretty sure they have some nice testers. But Haven Harbor also is one of the few marinas out here that has a good crew. Like most marinas out here have bottom standards that are testing your batteries or telling you need an alternator. Like you just qualify everything, ask a million questions. Because even on the bay, even on an inlet in the bay, it's no joke. I mean, no joke. So.
And on a customer service standpoint, and just this is a little off subject, but that's why sometimes I don't want you to think sometimes your techs are blowing you off. That's why sometimes when you see a tech on a dock and you're like, hey, I got a quick question, and you ask that tech that quick question, and the tech kind of goes, it's because they know it's not a quick answer. Like, we have to think about all these qualifying things that something sounds so simple. We have to think about everything else that's affected by it and how it all goes together. So a lot of times that shortness you see is not that we don't want to answer your question. It's that I know you think it's a simple question. For me to give you an intelligent answer, I have to do a whole lot going on up here, and see what I get information from you. So keep that in mind that, I know it should be simple, and it can be, but you have to think the whole thing through as a complete system, not as just this little item you're looking at.
Oh, I'm glad we're talking about this. This is what's important, Q&As and these questions. Me talking for 2 hours is going to bore you guys. Like, something as simple as that, like, you got to qualify. Like, do you have, for your alternator, do you have a single V pulley? Do you have a serpentine? Do you have a double V pulley? Like that question right there, like, it's, that's a very good question to ask. If you want to upgrade your battery bank, you're going to have to probably upgrade your pulley system while you upgrade your alternator, which is even more money, and it's a little bit more complex. If you want to get a a bigger battery bank, speaking of lithium batteries, I think Eric wants to get into, Curtis wants to get into lithium batteries too, so I won't go into it too much, but even understanding your charge rates, that internal chip in a battery is called a BMS, a battery management system. And there's a lot of different ways to think about a BMS. We manufacture some lithium batteries for custom applications, typically for the government, so we buy BMSs and we program BMSs quite a bit. So, like internal BMSs, like this battery right here has an internal BMS. This battery has a cylindrical cell, and in between each cell is a little MOSFET fuse. This battery has a C5 charge rate. This battery is 100 amps. And this battery you can typically take down to about 90% discharge and bring it back up to about 95% charge at the sweet spot all day and every day. So 100 amps, you can take 50 amps in 1 hour, it'll be fine. And then you look at a battery like this. This is more complex. This battery is the same size pretty much, but this is a 200 amp hour battery. This is made with prismatic cells, which are big brick cells that harness a lot more energy than a cylindrical cell. They just don't last as long. So this battery theoretically should be able to give you more cycles over the course of its lifespan than this battery. Well, for world cruisers who are going on a 2-year cruise, people seem to want more energy in a smaller footprint. So they buy prismatic cell batteries. And this battery too can take a C1 charge rate, which means a 200 amp battery can take 200 amps and be charged up in an hour, theoretically. So if you have the charging system to be able to handle it.
How many hours would that take on a wet cell, a typical wet cell battery? 1 hour at 200 amps, a 200 amp alternator.
3 or 4 hours, in the last...
That's the difference in the time it's going to take you. 3 to 4 hours to charge up your wet cells, an hour to charge up your lithiums.
Yeah, it's
here's where the math gets tricky with lithiums, and lithiums get kind of compound their benefit. So this is 200 amp hours, right? But I can use 90% of this battery. So my effective use of this battery is, 180 amp hours, right? If I have a 200 amp hour wet cell battery, I'm only allowed to use at most 50% of that, which means my actual use out of that battery is only 100 amp hours. So a 200 amp hour lithium ion versus a 200 amp hour wet cell, this is almost double the battery, even though the numbers are the same. Okay, again, why we need to look at the whole system, plan it out. Huge benefit. When we talk about size and space savings, it's because this is almost double the battery as the other one, just in its own size. Because I can use so much more of it.
That rate of discharge for the wet cells, does it also apply to the AGMs? Are they similar in that sense?
That's an agnostic question. It's all depending on the manufacturer and what their engineers have deemed an acceptable rate.
That's correct. Every battery will have specs, and if they don't want to give you specs on it, don't buy the battery. I'm just being honest with you. Every battery's going to have specs. I think some of these even have the specs literally printed on the battery.
Yeah. And that's just what the battery can take. Like also too, like what the battery can give is also another BMS parameter that can be preset at the factory. Like this battery, I believe, can give you 50 or 100 amps of a continuous discharge. This one can give you 400. So if you need the power, you have the power when you need it. So, and there's a price difference in these batteries, obviously. And there's other brands out there too, like you have your standard cylindrical cell lithium batteries, you have your Dakotas, you have your Relions, you have your Battleborns, that are all pretty much rocking 10, 15, 20-year-old technology and marketing it to the marine industry right now. And then you have a lot of companies out there that are, and just FYI, not a lot of really quality cutting-edge, new-age battery manufacturers will market to the marine industry first. They're trying to go after stationary power. They're trying to go after telecom. They're trying to go after alternative energy. They're trying to go after critical power. That's big customers, big POs, easy to manage, residual cash flow. Because the marine industry is so custom that a lot of manufacturers try to stay out of it. Like if you talk to the boys that started up Victron, and we've got a good relationship with Victron, we're one of their biggest distributors, like, they didn't even want to sell to the sailboat community. You guys just adopted them. You know what I mean? Like now they're in it. Yeah,
Well, Battleborn started pushing hard,
Yeah.
and everybody said, well, what if I don't want Battleborn? Who do I go with? And they were the only ones that had anything out there, even though they weren't pushing it for boats.
Yeah. There's a company that's pretty much like they're called Lithionics. They're a marine company, marine lithium battery company that is going after the marine market. But they're small, but they cater to the marine industry. Like there's a lot of due diligence on your part where if you get a guy like Erik or get a guy like Curtis to work for you, like they'll help you dial in your boat because everything is custom. Like that is the big thing. Everything is custom.
Yeah, I
Everything
remember
is custom.
this industry, we're like a hot rod shop. You know, you don't go in because it's a cookie cutter. You go in because you want something special. You know, every boat is special. Everything is a little bit different.
Excuse me.
Even,
You
go ahead.
talked about insurance before. I had heard that down in Florida, certain insurance companies, for sailors, you need to be ABYC certified to put these systems in. The insurance will ask. So can you talk to us about some of the risks of doing it wrong, the environmental temperatures, extreme cold, heat? Sailboats see a lot of extremes. So what are you sensitive to, and where are the risks of doing it wrong, and what could happen with a lithium package versus just beating up a wet cell battery? Like, they can really beat them up, but they're sensitive, right? They're sensitive to certain environmental factors.
Yeah, they're like a high maintenance wife. Like they'll make you dinner at night. You'll be happy with everything going on in the back end. It's just, you got to treat them right. You got to have everything dialed in.
So what could go wrong? We need to be sensitive to the installation and how you're charging them. I've heard some horror stories about people doing them wrong.
A lot of people that are doing them wrong are these sailboaters that are power boaters that are in semi-retirement mode, so they can't dedicate all their time doing it right. And they are buying really cheap cells that are highly volatile from unreputable manufacturers, and they're not backing each cell up individually with a fuse. They're not backing up the systems correctly with breakers. They're not backing up the system correctly with anything. Period. Like I'm trying to not be too much of a sales rep for you. Like we've done about 1,000 world cruising boats, like all in. Like when it comes to supporting, and for lithium upgrades, when it comes to supporting marinas or marine service techs or a fleet of whatever government agency we're dealing with, like we've never seen an issue. And when we do see an issue, when we do get called in, my lithium battery just burned up, like upon further inspection, the lithium battery was on fire, but it wasn't internally on fire. There was a fire externally that melted the lithium battery. So I've even seen fires melt lithium batteries that are reputably made by major manufacturers or sold by major distribution networks that will literally catch fire, but not internally. They have an external fire somewhere that will melt the battery, and the battery is still fine. Does that mean thermal runaway won't happen? No. The thermal runaway typically will happen if you have a nickel-based lithium battery on your boat, or a cobalt-based battery on your boat, or a manganese-based battery on your boat that is a lot of energy and a little footprint, and it's on a boat, and it's not everything's set the right way when it comes to charging or discharging that particular cell. Most of the marine lithium batteries that you're going to encounter that are sold by Erik and Curtis are iron phosphate, which is very safe chemistry. And to give you an example, if you were to put an iron phosphate battery in your cell phone, the battery would be the size of a brick. That's the difference in chemistry, from nickel and cobalt-based chemistry to iron phosphate-based chemistry. And remember earlier I was saying, like, a lot of manufacturers, reputable manufacturers, don't want to market to the marine industry because it's not scalable for them and everything's custom. Like, it doesn't matter because the sailboat community and the marine industry, you guys are all super smart for the most part. You guys are all doctors, lawyers, engineers, professionals in your industry, small business, large cap business, mid cap business owners that own boats. Like, you're smart guys, and you're always looking for more energy, cheaper, and a shorter time frame. Like, that's what you're looking for. You want to be efficient. You want to be smart about your boat. You have your family on it, you're going out in the bay, you're going out in the ocean. So like, even though manufacturers don't want to market and sell to the marine industry pulls these manufacturers in. So we're even doing right now sodium, titanium, graphene-based lithium batteries for certain marine applications. As long as who's ever installing it is ABYC Marine Electrical certified, and the insurance company doesn't raise all hell on the boat that it's going on. So once again, that answer is also a custom answer.
Well, it's also too, I think you're looking for like most of what happens, most of what I see from people doing them themselves, projects without getting the help, without, you know, getting the wire diagrams or anything. Most of the time, what they're doing is really a loose connection, because that would just bomb the whole system, one loose connection in the whole thing. That's where your fires are happening, because they're not checking their torque values. I just got, same thing like on a multi-plus, same thing that they're doing, mostly wiring issues, not cutting the wiring the correct lengths on your leg of the AC there, and just totally
leaving bare copper out.
Well, yeah, the bare copper out, and then you'll see it'll just melt that whole thing right in there. And then from that happening, you know, it could compound into something way worse. But that's most of the problems I see when people are trying to do it themselves, not getting the help, not, you know, asking the right questions, like the ferrule lengths, the loose connections, and then ordering the wrong components totally for your system. So that's why it's always good, like if you have the idea, you know, get with these guys, run it by them, like, hey, I got this here, these are my components, will they work? You know, then we can tell you, like, this is not gonna work with this, or this will work with that. But that's mostly the do-it-yourselfers, which most of the time, to be honest, there's not really that many problems, but the problems I do see is mostly the wiring, loose connections, or to the cold, extreme cold, that would be a problem too. But that's pretty much just wiring is what there's the problems I'm seeing with people doing themselves on lithium.
So everybody, when lithium ion first came to, well, first off, I want to thank these gentlemen for their time. They certainly didn't have to come out and share their wisdom and knowledge with us. We do greatly appreciate it. And I don't think they're going anywhere, but I was going to get into the lithium ion a little bit more because I know we're running short on time here.
Okay. Okay.
And just wanted to touch on some quick things, even in the lithium ion field. Well, let's start with when lithium ion first came to boats, people started talking about it. They started talking about boats burning to the ground and all of this stuff. And in the beginning, that was a risk because it really just was not figured out and thought out from the manufacturer standpoint. Now it is. So now, like they said, most of the time when big things like that happen, it's not actually the batteries that's causing the issue. It's other things in the installation or in the electrical system. Now, there are some quick and dirty things that we put out there as like no-nos, right? This year, combining lithium ion batteries with any other type of battery, that's a major no-no. Because again, where we talked about the speed that this battery can put in, or take in and put out power, this one's very slow.
Question on that.
Yes.
Can you have a house bank made up entirely of the lithium-ion batteries, but a starter battery that's...
Yes.
Yes, and this is exactly why he was talking about custom solutions, and that's why there's so many components here. So your main bank that you're charging, if it's lithium ion, you know, that whole bank should be lithium ion. Okay, now you can't use that charger to charge another bank because the batteries are of different chemistry. So what they use typically is they'll use like a DC to DC charger. Okay, so this charger's putting in 100 amps to this bank all the time, right? This is pulling out, depending upon what it is, let's say 20 amps off of the lithiums and feeding it to your engine battery. That's an AGM. Okay, this isolates the two banks. Okay, I cannot have a direct connection between these two pieces. It's very, very, very bad. Because this wants to suck in power and this wants to dump it out as fast as it can. So there are ways to have different banks. Where people start to get kind of, where it gets iffy and why you need to work with somebody is how many people here have a switch on their boat for their batteries that says 1, 2, 1 and 2, or A, B, A and B, right? So here's where it gets really tricky. This is on bank A. This is on bank B, right? But if even for a second I go to AB, I have now tied these two banks together with wire. That's really, 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 really bad. So when you go to a lithium ion system, if your whole boat is not lithium ion, you're going to end up using DC to DC chargers, things like that, to keep those banks completely separate. And you are losing your AB or 1, 2, 1 and 2, that 1 and 2, you're losing that. But if the system's set up properly, you'll never know that you've lost it, because this main bank will be charging so fast, these are pulling charge off of it, charging the other banks, and it'll all even out and take care of itself. But people want to go, okay, well, I just want to do this bank, and they already have that switch on their boat. First time they go to 1, 2, they've got major, major, major problems. Okay, so if you're going to do lithium ion, get somebody involved who can give you some guidance and help you figure out what you're doing. Simply missing the fact, and later on, or even, you know, a friend gets on your boat and they turn that switch, you got big problems.
So can you use lithium as a starting battery?
Yes.
Oh, okay.
Yes. I don't know how the industry feels on it as a primary starting. They probably lean away from it, am I right?
There's not too many that make the starting one because it's such high amperage.
Yeah,
Right.
it is doable. I wouldn't. I would typically do an AGM for your engine battery, and then do lithium ion for your house and other things like that. And with the DC to DC charger, it's going to constantly be charging itself, so you'll be in good shape. But in the lithium ion world, as he talked about chemistries in the batteries and the different ways they're made internally, and he talked about the BMS, there's a couple other things to be aware of in the lithium ion battery world. For instance, this battery and this battery, I know the internals are technically different, but for purposes here, we can see up to this point they're roughly the same height, they're the same size roughly, right? So the difference here is this has more electronics in it. This is actually the case for a smart battery. It has holes over here where wires would come out. Okay, the BMS that he was talking about that could be tuned or, you know, set for whatever you're doing. In this battery, with the Victron system, you can customize your BMS in this battery. You can watch what's going on in this battery. You can tell, it will tell you if any individual cell in this battery is overheating. This battery is smart and can communicate with you. This battery still has a BMS built into it, but we can't see what's going on. We're kind of operating blind and leaning on it to manage it, okay? And then, I don't know who still out there makes them, but I'm sure somebody does. There are still lithium ion batteries out there that don't have a BMS in them at all. Not for the marine industry, but that exist out there.
Yeah.
So the BMS has a plate in here, where if this were to get shorted, it separates, okay? And so these posts no longer are connected to the cells inside. That's the safety piece that's built into it. Like he said, like fuses, right? So this has that, but we can't tell what's going on with it. This battery has that, and we can monitor, see what's going on, troubleshoot. If you have a bank of 5 of these and a battery shuts down, once the first battery shuts down, you sometimes start to see other batteries shutting down. And the tough part is we don't know which battery was the issue. This one we can see, with a proper setup, we can see exactly which battery was the issue. And if we needed to, in an emergency, we could pull that battery out of the bank, get the rest of the bank wired back up and going, and continue on our way. Whereas here, we're kind of shooting in the dark, and they do make them without that. And that's a safety feature. So without that, you're kind of getting rid of all the seat belts, all the airbags, everything, and you're going, hey, I'm going to wing it like the Wild West. And I wouldn't advise it. Lithium-ion battery without a BMS is scary and sketchy. But with a proper lithium-ion system, it really can change the way you sail and use your boat.
Yeah, you know, you guys can see there's a lot of different components when we're wiring up that system. Here we've got a display, so we can monitor and check batteries and
control.
And it's right, you can wirelessly too.
Mm-hmm.
You can do it with your
from your phone, from your laptop.
So it gives you a lot of different applications. But then we have shunts. We have a lot of other components that have to be in that system for all this to work properly. So one of the things I want to point out, and I've seen this on blogs online. Oh, they make a lithium drop-in battery for my boat. So I can just take my lead acid out of there and I can put this in there and away I go. Not true. It isn't a drop-in, there's a lot of things we gotta consider, the wiring. So that stuff has to be updated and done correctly. So don't get fooled into thinking there's just a drop-in lithium battery I can stick in there and replace.
It's kind of like saying there's a drop-in V8 engine for every car. Well, I can make the engine so it'll drop in the car, but you're gonna have to modify the car and the wiring on the car and the motor mounts on the car, and the engine may be a drop-in engine. And it's gonna fit your car, and it's not gonna work right without modifying your car. Same thing with those drop-in lithium-ion batteries. The battery itself is ready to drop in. The boat's not ready to have the battery dropped in it. You have to prepare the boat.
You may have to update cabling size because of the amperage that you're trying to put in and the amperage that you're trying to pull out for the devices. So there are a lot of things you got to consider. The other thing too,
Eric, your alternator.
And your alternator, you gotta,
and voltage regulator.
Don't assume the alternator on the engine is the right alternator. It's not going to do the job. Right? So that's got to change.
And for all the sailboats, the engine itself, right? I mean, if you put bigger alternators there, you're taking horsepower off the engine.
You're going to lose some horsepower. You're going to put more
So you
load on the engine.
have that into account. That okay, I may have a 40-footer, but my engine is 30 horsepower.
Yeah.
Okay.
Yeah. So there's some things that you got to consider. The good news is with lithium batteries, is we can store a lot more energy in a smaller footprint, right? A lot less weight. So there are some benefits there that are very helpful. Where you might have had an 8D for your storage, now you could probably get away with a much smaller battery in lithium and not take up all that space.
By the math, if you were to go from a standard wet to a lithium, this is quick rule of thumb, not very scientific, but typically if you have two 8Ds on your boat, you could essentially replace that with one 8D lithium ion that weighs half of one of those 8Ds you have now and still have the same amount of power on your boat.
Yeah. So there's the benefits. There's some other interesting benefits in some of these lithium batteries. One is Rely-On battery, and I have brochures. We can actually order these batteries for you guys through a couple of our distributors. They're catering to some of the marine use. They even have lithium batteries that are designed to work with some of the newer outboards, also with Mercury and Yamaha. So you can actually use them as a starting battery for those systems, which is nice. So what's nice about a lithium battery for a starting system on a small boat with an outboard? What happens when the boat sinks? The battery goes underwater. Everybody knows what happened to a lead acid battery when it goes swimming and shorts out, right? These, if they have BMS built into it, they shut themselves off, so they don't short.
It sits storing power at the
just-
bottom of the bay,
It's sealed,
just
sitting
holding
there.
power.
Boat gets raised,
Someone to come down and-
rinse everything off, dry everything out, and you've got a battery that's still good. So your investment in that expensive lithium battery is still good. You don't have to buy a new battery, and also it hasn't shorted out and damaged all the wiring. How many people here have ever seen what happens to a boat that sinks, that has a large battery bank system in it, and that whole system goes underwater?
Sinks faster.
It sinks faster, yeah, that's one thing. The other thing is, when that battery is shorting out across those terminals, it usually damages a lot of the wiring that's connected to it. So all that wiring's got to be replaced. So there's some benefits there to going this route. Cost, yeah, there's a cost involved. Nick, what would you say the average lifespan for a lithium battery in the marine use environment treated properly?
3,000 to 5,000 cycles and an 80% discharge. So if you break it down cost per cycle, it's a lot cheaper than buying a lead acid battery, period.
Yeah.
Or a lot cheaper than buying an AGM battery.
Yeah.
And it's just real simple math. How much are you going to use your power supply? Are you a Chesapeake Bay weekend warrior, or are you a road cruiser? Are you going out of the hook for 3 and 4 days at a time without shore power? But ultimately, if you really break it down, your cost per cycle for the amount of energy that you get from your wet cell to your AGM, to your gel battery, to your lithium battery, to your prismatic cell lithium battery, like Lithium is much cheaper. Just upfront cost is a lot higher.
Yep. So that's another consideration. What would you say the average lifespan is of a wet cell in our region?
Wet cell that has in our region, 3
Yep.
years.
So 3 years out of a wet cell. So
How
every
many
3
cycles you think that is?
On a wet cell? Not many though, we around here.
Exactly. That's the point. The lithium ion, more than tenfold the amount of cycles that it's going to give you. So it is. It's upfront versus long run cost. Now, look, you're a boat owner, so you also know it's how long you plan on owning that boat. If you only plan on owning that boat for 5 years, it may be a simple decision to make. But and also, like they said, your weekend warriors, your day sailors, lithium ion may be a little bit too much of an investment for you and how much you use your boat. It's not for everybody. It's really not. But anybody that's going to spend more than 2 days on their boat at any given time, not plugged into shore power, it's the simplest, easiest decision to make your life so easy. It really is. It'll make you enjoy your time on the boat a whole lot more, not worrying about, hey guys, we're getting a little low, let's turn these lights down, you get into managing stuff and you're spending your vacation managing the power on the boat and not enjoying your vacation. So if you spend more than 2 days on your boat at any given time without power, that's when it pays off.
Yeah, I know every situation's different.
Right.
But what is the average upfront cost to do a conversion from AGMs to lithium?
Taylor?
I mean, we haven't done a ton of them so far. We did Stargazer last year. I don't know, because that also involved adding solar panels. That was like a $20,000 job, but that was multiple.
Yeah, it gets really tricky. How many of these do you have? And do you want this grade or this grade, right? Smart or not smart? Big difference per battery. Now if we're talking about a boat that has 8 of these batteries, our difference just got huge. And then what options do you want? Do you want to be able to turn certain circuits off when you want to control power or not? Because then you need more.
That's why I asked the average.
It gets no, but the average is like, okay, it could be anywhere from $5,000 for a very small 2-battery bank conversion, just that bank, not charging off of anything else, to $20,000 for a full, complete control system, and upwards from there. So the average is huge. That's why it's tough.
Yeah.
So currently I've got wet batteries, 440, so I got 220, when they're brand new operating correctly. I've got 220 hours on my half tank.
AGM or wet?
That AGM, they're wet right now, but I'm saying I'm looking to replace that. So if I'm looking to get a comparable 220 amp hours, 2 of the blue ones are going to be over 300.
This one or this
So
one?
the one of the light blue. That would give me, you said, 360.
That's 200 amp
That would be
hours?
180, 360.
That'll give you 360 between the 2 batteries.
So that would give you 360 if you could fit that in the same.
For 2 of those, yeah.
Yeah, that's my question.
So one of the points I would just want to make when it comes to cost, right, like Nick said, is in the long term, it's a cheaper cost over that time for the battery. Your lifespan in years might be closer to probably, 10 years?
Yeah, and that's another thing to think about too. Like, beware of the lithium battery company that's offering you 10-year warranties. Because that's usually an indicator that they have to sell off price and that the battery's pretty cheap. And I've taken 10-year warranty lithium batteries in previous projects, and I've zapped them in 3 years because I discharge them and recharge them 100 times a week. You know what I mean?
Yeah.
So it's everything has to be thought about. Like everything.
So, that wet cell, on average in our region, because of the temperature swing we have here and how we're using it, and the other thing you got to consider is the boat is always moving. It's in the water. Movement has, on lead acid batteries, that affects them. So vibration, movement, heat, cold. So 3 years isn't a very long time on set batteries. So every 3 years, you got 2 8D batteries in that boat, wet cells, and that's your average for having to replace them. That's an expensive every 3 years. AGMs, we can get a little further, probably anywhere, I'd say probably closer to 5.
It all depends on what you're drawing, but yes.
Right, but how they're treated.
Yeah, how they're treated. Up here, you guys have winter, and flooded in an AGM battery don't do well sitting on the hard in a boat for 6 months. 6 months is about the amount of time you get before that battery discharges from 12.8, which is fully charged, to about 12 volts, which is about no energy left in that battery.
With zero trickle draw on that battery,
Right.
which means no clocks are on in your boat. No microwave clock is lit up, no
That just
little
sets-
gauge panels lit up. That's with zero draw.
I can buy a lot of Trojans for $20,000.
Yeah, but can you afford the back surgery?
Yeah.
I have a crane that moves them over.
So,
But, you know, up in New England, when I've worked up in Maine and New Jersey and all that, most of the yards up there pull the batteries out of the boat for the winter and store them somewhere where it's usually an ambient temperature around 50, 60 degrees to keep the life of the battery better for those boat owners. So that's something you got to consider. We are here in the mid-Atlantic, we have a tendency to haul the boats out and we don't worry about it because it's a relatively short winter. But there's 3 months of sitting on land, you know, whether it's getting trickle charged or whether you've got a solar panel on there or you disconnect it and just let it sit. So we're not treating the battery very well.
So I have a pre-owned boat.
Yep.
I've had work done on it here for a couple of different opportunities. I've got multiple components that I see have been installed, but I am not exactly clear on what each one does. I'm assuming it would be a chargeable expense to have someone come aboard and walk me through all of those elements to explain what they're doing and what I should be on the lookout for.
You might spend maybe an hour.
I'd let Taylor, that's literally Taylor's wheelhouse.
Yeah, the marina changed out my battery charger. There was, when I first bought the boat, there was an issue with the starting harness that got burnt up, and that all had to be ripped out and replaced way back when. There was something recent where there was a blown fuse and a disconnected wire on a little box where the start battery is. So it's just little things like that, which if I had some more fluency in what those things were, might allow me to better handle the circumstances.
I would say, you know, immediately after we've done the work, if you wanted to meet and go over what we did, that's something we would do and not charge you for.
Okay.
If it's after the fact or if it's not related to work that we performed, and you wanted like somebody to go over your systems and kind of diagram it and explain it to you, then we would actually charge for that.
Yeah, diagramming kind of more like each, I know what each thing is responsible for.
Let me give you one later.
Well, I think you're good. You fixed the little box in the engine start battery box last fall. There was a fuse issue in the broken wire, but the charger, the battery charger was replaced, I want to say 4 years ago.
Yeah.
Maybe.
Anybody else want to come down?
This question.
You got more up there, Eric?
Yeah, with respect to you guys.
This is all just looking
Phone
at
has some issues with battery wires. They have a whole team of when you guys have way more knowledge and training than I have, how can I confidently?
Just so I know what things are.
Are we done?
While Eric's feeling a question real quick, does anybody else have any questions? I know we're getting close to noon, to the end, we're past it. Any other questions? Good?
Need to cover a little bit of battery charge, battery charge, and inverters.
What do you get? What do you want to go with?
Just inverters.
Just the difference between them?
We want to record this last session, all the conversations kill the whole tape, so we want to cover inverters, and then we'll be.
We're going to talk about chargers and inverter chargers here for just a couple minutes, and then we'll let everybody go on and enjoy your Saturday. I guess we'll start with basics. Does everybody here, raise your hand if you do not know the difference between a charger and an inverter charger.
Is there another technology
Okay.
that's in the works?
So it's really simple. It's literally just, for a charger, it's just charging your batteries. It's taking shore power in, right? And it's charging your batteries. An inverter charger does two things. Your shore power comes into the inverter charger. It can charge your batteries. However, right? And let's say you're hooked into shore power, so you've got your inverter charger on, it's charging your batteries. And let's say you're running your microwave, right? When you disconnect from shore power, you have lost your 110 volts to run your microwave. Because the power from the shore comes into this inverter charger and then goes out to charge your batteries, it also comes into this inverter charger and then goes to your AC breaker panel. So as soon as the shore power goes out, the inverter charger will kick on and draw from the batteries now to create the 110 volts you need to continue to use your microwave, okay? So the inverter charger is one piece that manages the incoming power to the boat and goes, we have power coming in, we want to supply power to the batteries. All of a sudden we don't have power coming in, we want to supply power to whatever AC powered devices you have on the boat that you want to keep up and running. So, you know, a lot of people go, well, I don't really use an inverter, stuff like that. And that's okay in certain situations. But when you go to a thought out power plan and you do, you know, a system like this Victron system, there are other ones out there you can do as well, it makes running the boat simple. So if you run an inverter charger, a control system like the Servo GX, you can have generator, shore power, inverter power. We have three different types of 110 volt power coming in now. Now I also happen to have solar out here that's charging, that can charge my batteries, not just my shore power, right? And I have wind out here that can charge my batteries. So when you do a complete system with an inverter charger as the heart of it and a control system, it doesn't matter what happens on that boat. While I'm microwaving, if I disconnect from shore power, this automatically kicks on, my microwave keeps running, right? And then my batteries get too low because I'm pulling from the batteries to the inverter to create the power for my microwave. The control system sees that, it tells my generator to kick on automatically, and it kicks on and charges my batteries back up so I can continue to have my AC power. So when you do the complete system with an inverter charger, it literally runs the power system for you. If it sees solar coming in, it goes, hey, we can draw back on how much we're pulling off of the shore power to allow more solar charging. You know, it can monitor the entire system. The upside to it is it's in a really beautiful graphic display in this particular setup that literally shows you a solar panel, a wind generator, your generator on your boat, the shore power, and it has lines that move that show you where your power is coming from, where is it going, how much power is coming in, how much power is being used on the boat, everything. So a lot of people think inverter chargers are solely for, I want to run AC when I'm out on the water. That's a good part of them, but they also can be the heart of an entire system on the boat. Whereas a regular charger is literally just that. It's just going to charge your batteries and that's all it's going to do. So each has benefits and downsides. This is much bigger than a standard battery charger, you know? But like I said, you can run, you spec it out for your boat, right? You can potentially run your air conditioners on your boat when you're on the water. You could run, yeah. I heard that. It can be done. You can run air conditioners, you can run your microwave, you can run a 110 volt refrigerator when you're out on the water, all of that. And an inverter charger can run that for you. Whether you're lithium ion or not. It can monitor and tell you how you're doing on your power. And then if you build it into a full system, of course, you can monitor the entire thing, and it does it all for you. It knows what's going on. It does tell you. You can go in and change it if you want to, but it's smart enough that it monitors everything on the boat and makes sure that you always have power when and where you need it. So inverter chargers are actually a good upgrade, and they make convenience on the boat so much easier.
A
They
lot
really
of,
do.
a lot of times, the only reason you might put an inverter on there is so you can watch your TV, use your laptop, charge your cell phone, something low consumption. You're going to have dedicated circuits on the AC panel from coming from the inverter. You wouldn't run your hot water heater. Typically, you wouldn't run your air conditioner on most circuits because you're going to have a fairly large battery bank for that kind of demand. So it's not as practical. Where I have seen it to run an air conditioner is on a small center console that has a small little cabin under the console so that they can run a small air conditioning unit in there for maybe just an overnight situation.
You're not going to run your air conditioner for your whole boat off of it, no. But you could run one small unit, let's say in your cabin, you know, where you're going to sleep at night. You
Might
wanna
be
keep
just
that cool.
might just be a fan. You know, you plug into an outlet, you're running a fan just to blow some air. But that's where the inverter comes in nice because now we don't have to run a generator or have a generator, listen to that noise, and do all that expensive installation. It's just another way that we can give ourselves some convenience with another source for power.
That was kind of my question. How much load can an inverter handle as opposed to just straight AC?
Depends on the size of the inverter. So they make some pretty large ones. You'll see a 4,000 watt inverter, which is a pretty good size one. But typical installation that you see on boats, especially if it's done by the manufacturer, it usually is just running like a refrigerator and a couple of outlets.
Maybe a TV.
Yeah, and that's about it. That's
The downside with inverting is, of course, we lose a lot of power. It's very inefficient to go from 12 or 24 volt to 110 volt. It's just inefficient. It is. We're spoiled. We like our TVs. We like our refrigerators. We like our air conditioners, right? So it certainly is the luxury. So it's inefficient. If you're going to do an inverter charger, I would definitely say you should have at least some sort of solar, some sort of wind, or some sort of generator, high output alternator, some way of getting these batteries back up if you've drawn too much with your inverter. You know, I wouldn't do it if you don't have some other sort of way of charging your batteries up on the water. But it can make life real nice on the water.
Does the inverter itself have a big power draw, or is it just the appliance?
So the inverters themselves are actually pretty efficient with that portion of it. The inverter is going to have a draw off of the batteries. And then the AC draw is coming from the refrigerator, let's say, to this. You know what I mean? So essentially, to run that 110 volt fridge, yes, you're pulling all of that power out of your batteries. So
the problem is you're converting direct current into alternating current, and there's loss in that conversion, which
at
is going
5
to be
times the power rate too.
it's
The power
going
factor.
to be heat. So these units will generate quite a bit of heat. So they also have to be mounted somewhere where it's got good ventilation and breathe. If you don't, I had a situation where the sailboater installed an inverter in the sailboat, put it behind the seating area because it was close to where the panel was or where the batteries were, put it in behind that seating panel. There's no ventilation. He mounted it sideways, right? The cooling fins and the cooling fan usually give you a direction which way it's going to be mounted. Typically upright or down like that, for the air to pass over the system to keep it cool. Well, because he mounted it into the enclosed space, wasn't a lot of breathing room, no ventilation, that inverter unit overheated. It lasted maybe about 3 months. And then he had to buy a new one because they would not cover it under warranty because it was not installed properly.
You literally just cook all the stuff on the board. What happens? You
So
cook all the resistors.
these are considerations with any charger, any inverter, even with the batteries. We need to make sure we have ventilation. Heat is a big problem. We want to get the heat away from it. Right? So if we put them in sealed areas where the heat can develop and not be able to escape or exchange, it's going to shorten the life of those devices and the storage equipment. So those are all things you want to consider.
Good. Any other questions?
Nick, do you have anything you want to add?
No, we could talk about this
All day, I know.
forever. It's, you know, it's just exciting and, you know, just, I guess, just don't, I have an old buddy, who used to go, don't scare. Don't scare. Yeah, I mean, between Haven Harbor and, you know, and then you have a nice boat, I mean, just become efficient, I mean, you talked about air conditioning earlier, like, dude, DC air conditioning right now is a home run. I mean,
Yeah.
It's really blown up.
Yeah, technology's just not going backwards. So, I mean, whatever you guys want to accomplish in your boat, I mean, it can be accomplished. So,
DC air conditioning.
yeah.
Lithium ion. And stay cool all day long.
We got boats that are out, you know, in the middle of the Pacific Ocean right now that, you know, are literally like 3 and 4 weeks into a cruise going from, I don't know, somewhere to somewhere. It's very far away that, you know, just, they're not even turning their engine on. You know what I mean? Like, it's anything you want to accomplish can probably be accomplished.
Yeah. Please feel free to reach out. Thank you all for coming. We do appreciate it. My personal belief is that an educated boater makes my life so much better because you know what you're doing out on the water. You lose less weekends. When you don't know what's going on in your boat, you go out on the weekend and something goes wrong and you lose that whole weekend, you're upset. Educated boaters can find a way around it and go, look, I'm not going to have everything, but I can do this and we can salvage the weekend, enjoy it, and those idiots can fix it during the week. So thank you for coming. I love to see the turnout. I love to see the questions. Please don't hesitate to get us involved. Even if you're just thinking about, hey, you know, trying to see maybe what I want to do with the boat next year. Maybe what do you want to do some upgrades or whatever. Talk to us. We're here to help you out. We're here to answer questions. We're here to help you figure out what's best for you, your boat, and the way you use it. So.
One thing I do want to bring up that I'd like to bring up at the end of the seminar, just as a reminder out there. I'm sure all of you are aware, due to how long it takes to get a technician on the boat during in season, because of the high demand and the unfortunate problem that we have with skilled labor. So there are, Maryland Marine Trades does have internship programs that are paid by the state and the marina to get young people involved in this industry so we can start developing people. So if you know young people who have an aptitude or are interested in getting into this line of work, please try to get them involved. They can call me. I can get them led in the right direction. But we are desperately trying to find the next generation of marine technicians. Unfortunately, we're getting older and we don't have as many people coming in behind us. And we'd all like to continue boating. We'd all like to have somebody be able to fix those boats and maintain them for us. So please take that in consideration when you're out there boating.
Spread the word. We need help.
Will you take semi-retired interns?
Yeah.